Hi friends, welcome to our YouTube channel Knowledge Academy. The main name of this lecture is to discuss about the signal and system formulas in a very detailed manner. And if you like the content of our channel, then please to like, share and subscribe our YouTube channel and don't forget to press the bell icon button. So whenever we upload a new video, the direct notice comes on our button. If any information in our video lectures, then please do comment in the comment section. We will definitely include all those information in the coming lectures. So why do we waste more time? So let's get started. The first concept that we are going to discuss is about the basics. The first concept that we are going to discuss is about the basics. So listen carefully. F of t minus t naught, f of t minus t naught, signal shifts by t naught and add t naught to the endpoints where the signal present. T naught can be positive, T naught can be negative. So basically here, suppose there is some original signal f of t. Suppose if you want to do the operation f of t minus t naught. So this is a standard notation. Always you are writing a standard notation. F of t minus t naught. Signal is going to shift by t naught. The signal is going to just shift. Means the signal we are going to shift either left side or right side, but without changing the anything waveform. Just we are going to shift that signal waveform that's it to the left side or right side, but we are not changing anything other than this. Then the signal is going to shift by t naught and add t naught to the endpoints where the signal present. So basically, for the previous means for the original signal f of t. So for the original signal f of t, you know the endpoints, right? For those endpoints, we have to add t naught. So for the two endpoints that you have the initial endpoint and the final endpoint, you need to add the t naught. Then you are going to get the new signal endpoints that you are going to get. So just draw the picture. So that is nothing but f of t minus t naught. So therefore, we can say t naught can be either positive, t naught can be even negative. So t naught can be positive, t naught can be negative. Suppose if t naught is equal to positive, then what's the meaning of this one? The signal is shifted to the right side. Or if t naught is equal to negative, means we can say the signal is going to shift to the left side. So listen carefully. If t naught is equal to positive, means the signal is shifting to the right side, and t naught is equal to negative, means the signal is going to shift to the left side. So these points always you have to keep in your mind. So suppose there is an original signal f of t. So for the original signal f of t, you know the endpoints. So you basically know the endpoints. So now what I am going to do, I want to do the operation of f of t minus t naught. So this is called as a shifting property. So we are going to shift the signal to the left hand side or the right hand side. So we are not doing anything other than this. So basically the signal is going to shift by t naught. So for the f of t, you know the endpoints, right? So you need to add this t naught to the endpoints. So you need to add this. You need to add t naught to the endpoints. Then we are going to get the new signal. So you are going to get the new signal. That is nothing but f of t minus t naught. So for the new signal, you know the endpoints, because for the previous signal f of t, you added the t naught, and then you got the new signal endpoints. Just draw that picture. So therefore, we are going to get the f of t minus t naught. T naught can be positive or T naught can be negative. If T naught is equal to positive, means the signal is shifted to the right hand side, and if T naught is equal to negative, means the shifted is shifted to the left hand side. Or simple, I can say if T naught is equal to positive, means the signal is shifted to the right hand side, or we can say the signal is delayed. If T naught is equal to negative, means the signal is shifted to the LHS, or we can say the signal is advanced. So finally, I can say simple words. Suppose there is a signal f of t. So for that signal, you know the endpoints. So you know the endpoints. So now basically, I want to do some shifting property for the signal f of t in order to get the f of t minus t naught. Then what I should do? So basically, for the previous signal f of t, you know the endpoints. Just add t naught for those endpoints. Then you are going to get the new endpoints. Just draw that picture. There is nothing but f of t minus t naught. T naught can be positive, T naught can be negative. T naught can be positive, T naught can be negative. If T naught is equal to positive, we can say the signal is shifted to the right hand side, or we can say the signal is delayed. If T naught is equal to negative, means we can say the signal is shifted to the left hand side, or we can say the signal is advanced. So this point always you have to keep in your mind. So now let's go for the another thing, which is f of at. F of at. The another modification is f of at. So what is the meaning of this signal? We will see here. Signal compresses or expands and divide by a to the endpoints where the signal present. A can be positive or A can be negative. Suppose that a signal f of t is there. So now I want to do some operation of f of at. F of at means it can even compress the signal, or either it can expand the signal. So basically we can say it is going to compress the signal, or whether it can expand the signal, but the amplitude of the signal will never change. Whatever the amplitude of the signal, it will never change. Only thing is the signal is going to compress, or the signal is going to get expand. So that is the meaning of f of at. So how to draw this picture? How to draw this picture from the f of t? Suppose for the f of t, you know the endpoints, right? So you know the endpoints. For those endpoints, divide by a. So divide by a to those endpoints, then we are going to get the new signal endpoints. So you know the initial point and the final point, or we can say initial endpoint and the final endpoint for the f of t. So for those, divide by a. So divide by a in order to get the new signal endpoints. So in order to get the new signal endpoints, that new signal is nothing but f of at. Suppose if a is greater than 1, then what is going to happen? If a is greater than 1 means we can say the signal is compressed. The signal is compressed. The signal is compressed. If a is less than 1, we can say the signal is expanded. Expanded. So these point always you have to keep in mind. So whenever the a is greater than 1, so a is greater than means, suppose that t is equal to 1 means I am going to get f of 2. So suppose I want t is equal to 1 means I am going to get f of 2. So it is basically compressing. It is compressing. If a is greater than 1, the signal is compressed. If a is less than 1 means the signal is expanded. A can be positive or a can be negative. So always remember the important point. So finally, suppose there is a signal f of t. So you know the endpoints, right? You know the endpoints. So I want to get a new signal which is f of at. Then what is the meaning of this one? See, if f of at means either it can do the compress the signal, original signal, or it can expand the original signal. Suppose if a is greater than 1, it is going to compress the original signal, and if a is less than 1 means it is going to expand the original signal. So how to draw this graph? So for the f of t, you know the endpoints. For those endpoints, divide by a. Then you are going to get the new endpoints. Then just drop the picture. We are going to get the f of at. A can be either positive or a can be negative also. If a is greater than 1, for 1 means we can say it is nothing but, if a is greater than 1 means we can say it is going to compress the signal. If a is less than 1 means we can say it is going to expand the signal. So these part always you have to keep in your mind. So now the next conversion is f of at plus b. F of at plus b. So here in the first case we have basically shifted the signal. In the second case we have basically compressed or expanded the signal. So the third one is the combination of these two things. Shifting as well as this compressing or expanding. So it is f of at plus b. F of at plus b. So how to do this one? Suppose if you know f of t, then how to get the f of at plus b, that we are going to discuss. Shifting followed by scaling. So first you have to do the shifting property, and then you have to do the scaling property. So this point always you have to keep in your mind. So first we have to do the shifting property, and then we have to do the scaling property. So what you have to do? Shifting followed by scaling. So this is an important thing always you have to keep in your mind. So from f of t, if you want to get the f of at plus b, first you have to do the shifting, and then you have to do the scaling in order to get the f of at plus b. A can be either positive, a can be either negative. Here b can be either positive, b can be either negative. So I've already told you, first you have to do the shifting property, and then you have to do the scaling property. Suppose there is a signal f of t. Listen carefully. Suppose there is a signal f of t. So what I will do? First I will basically do the shifting property. So if it is shifting property, then what I am going to get here? So let me go for the shifting property like this. So you can see, suppose some signal y of t is there. So now I am going to the shifting property. So shifting property I am going to do here. Then I will do scaling property. Then I will do scaling property, which is equal to scaling property. So y of t is there, st plus t by 80. Then you are going to get 80 plus p. So you can see clearly. So first I have did the shifting, then I have did the scaling. So the original signal is f of t, right? The original signal is f of t. Right? So what I did is very simple. So I have got a new signal y of t, which is a shifted of this signal by p by b. So I have made the new signal y of t, which is a shifted version of the f of t by some units b. Then what I did, I've taken another new signal, which is a scaling of the previous signal by A. Then wherever t is there, I replace t by at. Then I'm going to get f of at plus b. So you can see, first I did the shifting property, then I did the scaling property. So always remember, see, the shifting followed by scaling is the correct property of this one. So therefore, f of at plus b means first you have to do the shifting property, and then you have to do the scaling property. Then you have to do the scaling property. I've already told you how to do the shifting property. Shifting property is, so for the f of t, you know the endpoints. Just add t naught. Just add t naught to those endpoints in order to get the new signal, and endpoints. Then what I did, then for this new signal, I am going to the scaling property. So for this signal, you know the endpoints. Then just divide by a on the both the endpoints. Then you are going to get the new signal endpoints. Then draw a picture. You are going to get the overall signal. So first thing is, first you have to do the shifting property, and then you have to do the scaling property. A can be either positive or A can be negative. B can be either positive or B can be either negative. So always shifting followed by the scaling is the correct property that you always have to keep in your mind. So always you have to follow the shifting, then you have to go for the scaling in order to get this f of at plus b from f of t. So this is the thing always you have to keep in your mind. So if you know these two things, then you have to always get the other thing. So this third one is the combination of these first two things. So always shifting, then comes the scaling. So shifting followed by scaling is the correct way in order to get the f of at plus b. So this is the things always you have to keep in your mind. So now we are going to discuss the other concept, which is some properties of signals. So we are going to discuss some properties of the signals. See, even signal into odd signal is equal to odd signal. So whenever you are going to multiply an even signal with an odd signal, always you are going to get an odd signal. Similarly, whenever you are going to multiply an odd signal with an even signal, again we are going to get the odd signal. But if you are going to multiply two even signals, we are going to get again even signal. But if you are going to multiply two odd signals, we are going to get the even signal. So this is same as the numbers also. So listen carefully. Even number. So even number into odd number. So even number into odd number is nothing but. So basically that is not the case with the numbers, because 2 is the even number and 3 is the odd number. But overall you are going to get the even number, right? So that is not with the numbers. So just you have to keep in your mind this one, which is even signal to odd signal is always equal to odd signal, and odd signal to even signal is equal to odd signal, and even signal to even signal is equal to even signal, and odd signal to odd signal is again even signal. So these things always you have to keep in your mind. So always remember, even into odd is equal to odd, odd into even is equal to odd, even into even is equal to again even, again odd into odd is again equal to even. So this point always you have to keep in your mind. So therefore, these are the properties of these signals. So even signal into odd signal is equal to odd signal into even signal is equal to odd signal, even into even signal is equal to even signal, odd into odd signal is also equal to even signal. So this is what I am trying to tell you. So you can see only, see, so whenever you have like this, both even to even is again even signal, odd into odd is also equal to even signal, even to even is again equal to even signal, odd signal to odd signal is also equal to even signal. So when I can say even signal into odd signal is equal to odd signal, odd signal into even signal is equal to odd signal, even signal into even signal is equal to even signal, and odd signal into odd signal is also equal to even signal. So this point always you have to keep in your mind. So see, what is the meaning of even signal? Even signal means if f of t is equal to f of minus t, then we can say it is said to be even signal. If f of t is equal to minus f of minus t, then we can say it is said to be an odd signal. So this point always you have to keep in your mind. So if f of t is equal to f of minus t, then we say it is an even signal. If f of t is equal to minus of f of minus t, then we can say it is an odd signal. So this point always you have to keep in your mind. So if f of t is equal to f of minus t, then we say it is an even signal. If f of t is equal to minus of f of minus t, then we say it is an odd signal. So these things always you have to keep in your mind. So always remember, which is f of even signal means f of t is equal to f of minus t. Odd signal means f of minus t is equal to minus f of minus t. Sorry, f of see, listen carefully. What is the meaning of even signal? Even signal means f of t is equal to f of minus t, and odd signal means odd signal is very simple. So basically, I have written the somewhat difference I have written, but finally you may be able to understand what I am trying to tell you. So listen, you can write in the anyway, but I will try to write in the standard notation. If I write in the standard notation, then you can easily able to understand. So listen carefully. Even signal means, if even signal means f of minus t is equal to f of t, then we say it is a even signal. If f of minus t is equal to minus f of t, then we say it is a odd signal. Basically, I have to in the reverse fashion, but this is the actual statement. So listen carefully. What's the meaning of even signal? If f of minus t is equal to f of t, then we say it is a even signal. And odd signal means f of minus t is equal to minus f of t. Then this is called as the odd signal. Then the derivative of even signal, we are going to get odd signal, and the derivative of odd signal, we are going to get the even signal. So vice versa. The derivative of even signal, we are going to get odd signal. The derivative of odd signal, we are going to get the even signal. So this is a simple thing always you have to keep in your mind. So always remember, derivative of even signal, you are going to get the odd signal, and derivative of odd signal, you are going to get the even signal. So these things always you have to keep in your mind. So therefore, so always these properties always you have to keep in your mind. So what are the properties? Even signal means f of minus t is equal to f of t. Odd signal means f of minus t is equal to minus of f of t. Even signal to odd signal is equal to odd signal. Odd signal to even signal is equal to odd signal. Even signal to even signal is equal to even signal. Odd signal to odd signal is equal to even signal. And derivative of even signal is odd signal, and derivative of odd signal is even signal. So vice versa. Reverse of this one. So this one always you have to keep in your mind. So now the next property is, suppose if f1 of t is an even signal. Suppose if f1 of t is an even signal and f2 of t is an odd signal, then what is going to happen? Listen carefully. The integration from minus a to a, f1 of t dt is equal to 2 times of integration of 0 to a, f1 of t dt. See, because f of t is an even signal, so instead of doing from minus a to a, I can do from 0 to a and multiply by 2, because then I am going to get the same thing. So therefore, because the signal is said to be an even signal, so whatever the waveform from minus a to 0, same will be the waveform from 0 to a, because there is a even signal. So instead of doing from minus a to a, I will go for 0 to a and then I multiply by 2 in order to get the overall value. So therefore we can say, if f1 of t is an even signal, instead of doing the integration from minus a to a, I will do from 0 to a and multiply by 2, because from minus a to a, 0 and 0 to a, the waveform of f of t is f1 of t is same. So that is the reason I have did like this. So therefore, if f1 of t is an even signal, then integration from minus a to a, f1 of t dt is equal to 2 times of integration from 0 to a, f1 of t dt. As I already told you, here f2 of t is an odd signal, then integration from minus a to a, f2 of t dt is equal to 0, because from minus a to 0, the signal is a reverse. The signal is, we can say, if from 0 to a, if it's a positive means the signal which is from minus a to 0, it will become negative. So quite opposite. So posterior and negative area, they are going to get cancelled, and overall value we are going to get, it is equal to 0. So this point always you have to keep in your mind. So that is the reason I am doing like this. So therefore, when f1 of t is an even signal, the integration of minus a to a, f1 of t dt is equal to 2 times of integration of 0 to a, f1 of t dt. Whereas f2 of t is an odd signal, so therefore integration from minus a to a, f2 of t dt is equal to 0, because I have already told you, I explained in a very in a easy manner also I have explained. So these things always you have to keep in mind. So let me draw this one, the picture, so that you can easily able to understand. So let me draw a small picture so that you can easily able to understand what I am trying to tell you. So you can see clearly here. So this is the basically some signal, like this is that. So this is basically even signal, whereas the other thing is a odd signal. So you can see clearly. So you can see quite clearly. You can see clearly from the picture. So in the first case, so this is some example of f1 of t, and this is the example of the f2 of t. So therefore we can say simply that f1 of t is an even signal and f2 of t is an odd signal. So you can see clearly this waveform and this waveform from minus a to 0 and 0 to a are equal, whereas here it is quite opposite. So this is a positive and negative area, so overall they are going to get cancelled. So this is what I am trying to tell you. So finally I can say, if f of minus t is equal to f of t, then we say it is an even signal. If f of minus t is equal to minus of f of t, then we say it is an odd signal. And even signal into odd signal is equal to odd signal, and odd signal into even signal is equal to odd signal. Even signal into even signal is equal to even signal, and odd signal into odd signal is equal to even signal. And derivative of even signal is odd signal, and derivative of odd signal is even signal. And when f1 of t is an even signal, the integration from of minus a to a f1 of t dt is equal to 2 times of integration of 0 to a f1 of t dt. And if f2 of t is an odd signal, then integration of minus a to a f2 of t dt is equal to 0, because I have explained all these things in a very easy manner. So these things always you have to keep in your mind. So now we are going to discuss the other concept. Listen carefully. Remember the formulas. The concept is remember the formulas. So these formulas always you have to keep in your mind. So R of AT is equal to A into R of T. R of AT is equal to A into R of T, where A is greater than 0. So basically here this signal is nothing but it's a ramp signal. So this is the ramp signal. So this is going to hold only for A greater than 0. So R of AT is equal to A into R of T, and this condition is going to hold only for A greater than 0. So what is the meaning of R of T? R of T is equal to T into U of T. So what is R of T? R of T is equal to T into U of T. So R of T is nothing but this is a ramp signal. So this is the ramp signal. So this point always you have to keep in your mind. So R of AT is equal to A into R of T. So in place of T, if you substitute AT, then what you are going to get? AT into U of AT. U of AT is nothing but it is again U of T. So U of AT is nothing but, see, what is U of T? U of T, the initial point is 0 and the final point is infinity. So U of AT means I am basically doing the scaling property. So therefore, I need to divide by A on the both sides. 0 by A is equal to 0. Infinity by A is nothing but again infinity. So signal is same as it is. So therefore, we can say U of AT is nothing but it is U of T. So U of AT is nothing but U of T. So therefore, we can say, so R of AT is equal to AT into U of T. So A, if you take A common, then what you are going to get? A bracket T into U of T. So T into U of T is nothing but it is equal to again R of T. So this is going to hold only for A greater than 0. So but not for A less than 0. A less than 0 means there will be that is not the case that we are going to discuss. Only for A greater than 0, this is going to get hold. So therefore, R of AT is equal to A into R of T, and it is going to hold only for A greater than 0. And you know R of T is equal to T into U of T, and U of AT is always equal to U of T. U of AT is always equal to U of T. So these point always you have to keep in your mind. So therefore, we can say finally R of AT is equal to A into R of T, where A is always A must be always greater than 0. A must be always greater than 0. This is going to hold only for A greater than 0. And R of T is nothing but it's T into U of T. So we can say it is a unit ramp signal. Then the another formula is integration of minus f2 plus f2 delta of t dt is equal to 1, because the area under the impulse function is nothing but it is equal to 1. So therefore, integration of minus f2 plus f2 delta of t dt is equal to 1, because the area under the impulse function is equal to 1. Integration is basically we are going to find the area of the signal. So integration from minus f2 plus f2 delta of t dt is equal to 1. So therefore, we can say the area under the impulse function is always equal to unity. The next point is delta of AT is always equal to 1 by mod A delta of T. So where A can be positive or A can be negative. So this is a very, very important formula that you always have to keep in your mind. So delta of AT is nothing but which is equal to 1 by mod A delta of T. 1 by mod A delta of T, where A can be positive or A can be negative. Here always modulus means always you have to take the positive value only. If A is positive or A is negative, so modulus means always you are going to get the output as positive only. So this point always you have to keep in your mind. So here I can write like this. Then what is the delta of 2t? Delta of 2 is equal to 1 by A is 2. So 1 by mod 2 is nothing but 1 by 2 only. 1 by 2 is delta of t. Or suppose if you want delta of minus 2t, then here 1 by minus mod of minus 2. So mod of minus 2 is nothing but plus 2. So 1 by 2 into delta of t. So this is what I am trying to tell you. Even you take positive or even you take negative, we are going to get the same thing. So therefore, always remember delta of AT is always equal to 1 by mod A delta of t, where A can be positive or A can be negative. Because you know the graph delta of t is symmetric. So that is the reason we can say it is going to like this. So therefore, we can say finally delta of at is always equal to 1 by mod a delta of t. So we can say like this, if a can be positive or a can be negative, a can be positive or a can be negative. So from this what we can say, as both the r's are equal, so h is also equal to equal. So delta of 2d is nothing but which is equal to delta of minus 2 2d also we can say, because as r's are equal, so definitely the LHS are also equal. So finally I can say delta of at is equal to 1 by mod a delta of t, where a can be either positive or a can be either negative. So because I already told you delta of t, whenever you are going to do this, so some more analysis about delta of t, there it is symmetric with respect to my axis. So because of this reason only they are going to become equal. So delta of 2 is nothing but 1 by 2 delta of t, and delta of minus 2 is delta of minus 2 it is nothing but 1 by 2 delta of t. As both r's are equal, so this is also equal. So delta of 2t is equal to delta of minus 2t. So this point always you have to keep in your mind. So finally I can say delta of 8 is always equal to 1 by mod a delta of t. A can be either positive or a can be either negative. The next property is delta of at minus b is equal to 1 by mod a delta of t minus b by a. A can be either positive or a can be negative. So how to do like this? Let me tell you here. So delta of at minus b. So here what I will do, I will take a inside common. If I take a inside common, then I am going to get like this. So I am going to assume this inside one t minus b by a. I am going to assume like t, the previous concept. So like previous concept, then what we can do? Then what we can apply, which is equal to 1 by mod a delta of t minus b by a. Just by the previous concept, just by applying the previous concept, we have got this one. So therefore always remember delta of at minus b is nothing but 1 by mod a delta of t minus b by a. So what I have done, basically I have taken inside a as a common. So delta of at minus b means initially I have taken a as a common. So delta of a common t minus b by a. Just by applying the previous property, then I am going to get it is equal to 1 by mod a delta of t minus b by a. A can be positive or a can be negative. So this point always you have to keep in your mind. So finally I can say delta of at minus b, it is equal to, we take inside a as a common, then we are going to get delta of a common t minus b by a. By applying the previous concept, we can take a outside, which is equal to 1 by mod a delta of t minus b by a. A can be either positive or a can be either negative. Then the differentiation of the ramp signal, it is equal to unit signal. I have already told you the derivative of the ramp signal is nothing but it is a step signal. It is a step signal because you know d by dt of, so d by dt, so d by dt of, we can say t is nothing but, if you do the derivative we are going to get 1, which is nothing but step signal. So we can say it is a step signal. So therefore the derivative of the ramp signal is nothing but it is a step signal, which is u of t. Then what is r of t? Reverse. If step signal is a derivative of the ramp signal, means the ramp signal is the integration of the step signal. So r of t is equal to integration of minus f to t delta of t dt. So we can write like this. We can either write this one like this also, u of t convolution of u of t also we can write. So you can either write this one or either you can write this one. Both are same. So u of t convolution of u of t also we can say. So you can see the step signal is a derivative of the ramp signal. So the ramp signal is the integration of the step signal. So r of t is equal to integration of minus f to t delta of t u of t dt. So we can write like this one also, which is u of t convolution of u of t also. Like this also you can write. So therefore we can say finally that as the step signal is a derivative of the ramp signal, so the ramp signal is the integration of the step signal. So therefore r of t is an integration of minus f to t u of t dt. You can also write like this, which is u of t convolution of u of t also you can write. So this one I will tell you in the coming class, concepts why I have done like this also. So this point always you have to keep in your mind. Then the next point is the derivative of the step signal. The derivative of the step signal is nothing but the derivative of the step signal is nothing but a impulse signal. So the derivative of the step signal is nothing but it's an impulse signal. So d by dt of u of t is nothing but delta of t. Then if the step signal is a derivative of if the impulse signal is a derivative of the step signal, then the step signal is the integration of the impulse signal. So u of t is equal to integration of minus f to t delta of t dt. So you can write like this. So therefore we can say the impulse signal is a derivative of the step signal. So Therefore, the step signal is the integration of the impulse signal. So listen carefully. The impulse signal is a derivative of the step signal. So step signal is the integration of the impulse signal. So listen carefully. The impulse signal is a derivative of the step signal. So step signal is the integration of the impulse signal. So u of t is equal to integration of minus f to t delta of t dt. So this point always you have to keep in your mind. Then comes the other formula, which is sinc of t. Sinc of t is nothing but sin pi t by pi t. So this formula always you have to keep in your mind. So I already told you sinc of t. Sinc of t is nothing but sin pi t by pi t. Here t is a dummy variable. Either you can use t or either you can use x. Anything which is a common formula. So t is a dummy variable. So sinc of t is nothing but sin pi t by sin pi t by pi t. Then what is sinc psi x? So psi x is nothing but sa t. Suppose sa t you are going to use, which is equal to sin t by t. So sin t by t. So this is formula always you have to keep in your mind. So sinc t means sin pi t by pi t. Sa of t is nothing but sin t by t. So this is two important formulas always you have to keep in your mind, because definitely they will be asking some questions from this concept. So sinc of pi t is equal to sin pi t by pi t, and sa of t is equal to sin of t by t. So this formula always you have to keep in your mind. So finally I can say sinc of t is equal to sin pi t by pi t, and sa of t is equal to sin t by t. So these two important things always you have to keep in your mind. So these two are definitely used in the Fourier transforms. So that is the reason these two formulas always you have to keep in your mind. So therefore we can say finally sinc t is nothing but sin pi t by pi t, and sa of t is equal to sin t by t. The only difference between these two things, adding extra pi in numerator and the denominator. This replace t by pi t. Then you are going to get this one. That's it. So I can say like this, right? So then what I can say? I can say like this, right? Sinc of t is nothing but sa of pi t. So sa of pi t. So I can write like this. So in place of t, if you substitute pi t, then we are going to get this value. So therefore sinc of t is equal to sa of pi t. So this is one more thing I can say. So but anyway, you have to remember these two formulas. Sinc of t is equal to sin pi t by pi t, and the sa of t is equal to sin t by t. Then if you compare these two things, you can say sinc of t is equal to sa of pi t. So you can, because here if you replace t by pi t, we are going to get both the same. So finally I can say sinc of t is equal to sin of pi t by pi t, and sa of t is equal to sin t by t. So these two formulas always you have to keep in your mind. Then comes the other formula, delta of n is equal to u of n minus 1. So that we can say the first difference between the step signals, then we are going to get the impulse signal in the time domain, in the discrete time. Whereas the previous concepts all about the time domain, but this one is regarding the discrete time domain. So delta of n is equal to u of n minus 1. So the first difference of the step signal, you are going to get the impulse signal in the discrete time domain. So delta of n is equal to u of n minus 1. So these things always you have to keep in your mind. So this is so up to now we have discussed about the continuous time domain, but these are the formulas regarding the discrete time domain. So delta of n is equal to u of n minus 1. So we can say the step signal is in the discrete time domain. The step signal is the first difference of the unit step signal. So delta of n is equal to u of n minus 1. So these things always you have to keep in your mind. Now we are going to discuss the another point, which is R of n is equal to sigma k is equal to 1 to infinity u of n minus k. So basically I can say in the discrete time domain, I can write the ramp response, which is equal to sigma k is equal to 1 to infinity u of n minus k. It is a delay summation of the step responses, that is nothing but R of n. So basically I have already told you in the continuous time domain, I have already told you, which is the ramp signal is the integration of the step signal. So here in the case of discrete time, the integration will change to summation. So therefore R of n is equal to sigma k is equal to 1 to infinity u of n minus k. So in the continuous time domain, the ramp signal is the integration of the unit step signal. But if you go for the in the discrete time domain, then R of n is equal to sigma, because this integration will now changes to summation. So sigma k is equal to 1 to infinity u of n minus k, u of n minus k. So you can also write like this, which is sigma k is equal to 0 to infinity k into delta of n minus k also we can write. Means we can write in the format of the impulse signal also we can write, which is equal to k is equal to 0 to infinity k into delta of n minus k. And we can say the delay summation of the, it is a summation of the impulse responses. So in this fashion also we can write sigma k is equal to 0 to infinity k in delta of n minus k. And also you can write it is equal to sigma k is equal to minus infinity to n minus 1 u of k. So k value changes from minus infinity n minus 1 u of k also we can write. So these are the different ways of representation of the R of n in the discrete time domain. But if you ask me what is the expression of R of n, simply we can say the R of n is equal to, so R of n is equal to n for n greater than or equal to 0 and is equal to 0 otherwise. So this is we can say the actual representation of the impulse, we can say the ramp signal. So in the discrete time domain, R of n is equal to n for n greater than or equal to 0 and is equal to 0 otherwise. So these are the different ways of representation of the R of n in the terms of step signal, in the terms of impulse signal, in the terms of step signal also. So these are the different ways that we can represent. Similarly, suppose if I want to represent the u of n in a different way, how I am going to write, which is u of n is equal to sigma k is equal to 0 to infinity delta of n minus k. I have already told you, which is the step signal is the integration of the impulse signal. So in the continuous time domain, but if in the discrete time domain, that integration will not change to summation. So u of n is equal to sigma k is equal to 0 to infinity delta of n minus k. So k value is varying from 0 to infinity. Or you can also write this sigma k is equal to minus f to n delta of k also we can write. See, k is varying from minus f to n. Suppose if n is less than 0, this value is always equal to 0. But if n value is greater or equal to if the value of n is greater than or equal to 0, then this value is always equal to 1. So therefore, yes, it is going to represent the u of n also. You can also write which is r of n plus n minus r of n. Like this way also you can write. So these are the different ways of representing the u of n. So u of n is equal to sigma k is equal to infinity delta of n minus k, or sigma k is equal to minus f to n delta of k, or u r of n plus n minus r of n. So these are the different ways of representing the u of n. So now listen carefully. Suppose if f of t is any general real signal. Suppose I am going to assume f of t is any general real signal. Real signal means there is no complex terms in the signal f of t. Then I can write f of t as a summation of given signal as well as the odd signal. So suppose if I have taken f of t any general real signal means there is no complex number in that signal f of t, then I can write that signal as a summation of the even signal plus the odd signal. So I can do the summation of this f of t any general real signal I can write in the summation of the even signal plus odd signal. So f of t is called even signal and f of t is called as the odd signal. So f of t is nothing but f of t plus f of minus t by 2. So if you want the even part of the signal, then you have to use the property which is f of t plus f of minus t by 2. Then if you want f naught of t, which is equal to f of t minus f of minus t by 2. So this point always you have to keep in your mind. Suppose if you want to find what is the even nature f of t, it is nothing but f of t plus f of minus t by 2. And if you want the odd signal f of t, f naught of t, then you have to subtract f of t minus f of minus t by 2. See how it is like this, very simple. So you know f of t. So if I want f of minus t, f of minus t is wherever t is there, just replace t by minus t, then you are going to get f of minus t plus f of minus t. See I have already told you for even signal f of minus t is equal to f of t. So this is an even signal, so therefore it will become f of t only. Whereas this one, see in the case of odd signal, f of minus t is equal to minus of f of t, so therefore it will become minus of f naught of t. So this is the f of minus t. Then suppose let me assume this is the equation 1. So this is the equation 1 and this is the equation 2. If I add these two signals, then I am going to get f of t. So f of t is called f of t plus f of minus t by 2. Suppose if I want the odd signal, just do subtraction of this minus this, so 1 minus 2, then we are going to get f naught of t, which is equal to f of t minus f of minus t by 2. So these things always you have to keep in mind. So therefore we can say any real signal, I can write the summation of the terms of summation of even signal plus odd signal. So f of t is equal to f of t plus f of minus t by 2, and f0 of f0 of t is equal to f of t minus of f of minus t by 2. So these point always you have to keep in mind. So any real signal I can write in the terms of summation of the even signal as well as the odd signal, and the even signal is f of t plus f of minus t by 2, and the odd signal is f of t minus f of minus t by 2. So these things always you have to keep in your mind. So now let's go for the other point, which is suppose if f of t is any general complex signal. Suppose f of t is any general complex signal. So what's the meaning of complex signal? If in a signal, if you see any j terms, then we can say it is a complex signal. Then f of t is any general complex signal. Then I can write the signal as a summation of the even conjugate signal as well as the odd conjugate signal. So even complex signal plus odd complex signal also I can write. So f of t is equal to even complex signal plus odd complex signal. So if you want the even complex signal, which is a summation of this one, same as the previous one, but wherever f of minus t is there, just keep conjugate there. So wherever f of minus t is there, just keep conjugate there. So f of t plus f of minus t whole conjugate by 2, and the odd complex signal is equal to f of t minus f of minus t by 2. So just keep here conjugate. So wherever f of minus t is there, just keep the conjugate above. Just keep the conjugate above. Then we are going to get this format. So what I'm trying to tell you is very simple. So if you remember the previous formula, then you can get this formula just by replacing f of minus t as f of minus t whole conjugate. So this is what I'm trying to tell you. So wherever f of minus t is there, just replace f of minus t by f of minus t whole conjugate. So if you keep like this, then you are going to get these formulas, and remaining everything is simple. So therefore we can say that I've already told you any general complex signal you can write as summation of the even complex signal plus odd complex signal. And if you want the even complex signal, which is f of t plus f of minus t whole conjugate by 2, and if you want odd complex signal, then which is f of t minus f of minus t whole, it is a conjugate by 2. So I've already told you, if you remember this previous formula, you can get this formula in a very fraction of second just by replacing f of minus t as f of minus t conjugate. So this is what I'm trying to tell you. So now the next property is signum of t. What's the meaning of signum of t? Signum of t is equal to v of t minus v of minus t. So signum of t is Sgn of t is nothing but signum function. Sgn of t is called as a signum function. So if you want to draw the graphical representation, so like this you are going to get. So this is the graphical representation of the signum function. So this is a graphical representation of the signum function. So this is the graphical representation of the signum function. So this is minus 1, this is plus 1. So this is nothing but u of t, and this is nothing but minus of u of minus t. Just to the addition of these two things, two signals, then we are going to get signum of t. So therefore signum of t is equal to u of t minus of u of minus t. So u of t is nothing but this is the signal u of t, and minus of u of minus t is nothing but this signal. So with the addition of these two signals, then we are going to get the overall signal, which is called as the signum of t. So signum of t is equal to u of t minus of u of minus t. So this Sgn of t is called as signum function. So these things always have to keep in mind. So the next point is, suppose if f of t is a complex valued signal. So what is the meaning of complex valued signal? I have already told you, which is for the signal, if any complex j term is there, then we say is a complex signal. So if in a signal f of t, if you see a j value, imaginary part, then we can say it is a complex signal. So if f of t is a complex valued signal, then if f of t is equal to f conjugate of minus t, then the complex even valued signal or complex conjugate signal. So if f of t is equal to f conjugate of minus t, then it is called as the complex even valued signal or even conjugate signal. So listen carefully. If f of t is equal to f conjugate of minus t, then the signal is called as the complex even valued signal or even conjugate signal. Suppose if f of t is equal to minus of f of minus t whole conjugate, then it is called a complex odd valued signal or odd conjugate signal. So this is what I am trying to tell you. See, basically I have already told you, See, I've already told you one important point, which is suppose there is a signal f of t. How to know it is a even signal or not? Suppose it's a real valued signal. It's a real valued signal means there is no imaginary tone in that. Then it is called as an even signal when f of t is equal to f of minus t. Suppose if f of t is equal to minus of f of minus t, then we can say that it is called as the odd signal. If f of t is equal to f of minus t, then we say it is a even signal. And if f of t is equal to minus of f of minus t, then we say it is a odd signal. This is for a real valued signal, means there is no imaginary part. Suppose if it's a complex valued signal, means there is a j imaginary part. Then how to define that one? Which is, I already told you, replace f of minus t by f conjugate of minus t. So wherever f of minus t is there, just replace f of minus t by f conjugate of minus t. So here, f of t is equal to f conjugate of minus t, then we can say it is a complex even valued signal or even conjugate signal. Then, if f of t is equal to minus of f conjugate of minus t, then we say it's a complex odd valued signal or odd conjugate signal. Same thing. This is for the real valued signal and this is for the complex valued signal. So finally I can say, if f of t is a real signal means there is no imaginary part. Then if f of t is equal to f of minus t, then we say it is a even signal. And if f of t is equal to minus of f of minus t, then we say it's a odd signal. We can say these are the real signals, right? Real signals. Then for the f of t is a complex valued signal means there is some imaginary part. Then so I've already told you, replace f of minus t by f conjugate of minus t. So if f of t is equal to f conjugate of minus t, then we say it is a complex even valued signal or even conjugate signal. And similarly, if f of t is equal to minus of f conjugate of minus t, then we say it is a complex odd valued signal or conjugate signal. So these things always you have to keep in your mind. So even complex even valued signal or even conjugate signal or complex odd valued signal or odd conjugate signal. So these things always you have to keep in your mind. The next point is delta of t square minus a square is equal to. So delta of t square minus a square, how we are going to write? So basically, this is t square minus a square, I can write like this, a square minus b square is equal to a plus b into a minus b, right? So therefore, we can write like this. So finally, we can write like this, which is equal to 1 by 2 of mod a delta of t plus a plus delta of t minus a. So this is the important formula always you have to keep in your mind. So delta of t square minus a square is equal to 1 by 2 mod a delta of t plus a plus delta of t minus a. So this is a very, very important formula always you have to keep in your mind. So therefore, we can say that delta of t square minus a square is equal to 1 by 2 into mod a delta of t plus a plus delta of t minus a. So this formula always you have to keep in your mind. So delta of t square minus a square is equal to 1 by 2 mod a into delta of t plus a plus delta of t minus a. So this formula definitely we have to remember. So we can say delta of t square minus a square is equal to 1 by 2 into mod a into delta of t plus a plus delta of t minus a. So this is a very, very important formula. So finally I can say delta of t square minus a square is equal to 1 by 2 into mod a into delta of t plus a plus delta of t minus a. So this formula always you have to keep in mind. The next point is, if y of n is equal to sigma k is equal to minus infinity to n x of n. Suppose for some system they are given y of n is equal to sigma k is equal to minus infinity to n x of n. So this is in the discrete time domain. In the continuous time domain, means definitely it is an integration. The output is an integration of the input. So see, basically in the continuous time domain means output is an integration of input. In the discrete time domain means we have to represent the integration by summation. So we are going to get y of n is equal to sigma k is equal to minus infinity to n x of n. So we can write like this, right? So I can write like this. So if you see clearly what I can write like this. Y of n is nothing but, here I can write like this, sigma k is equal to minus infinity to n minus 1 x of n plus I can write like this, x of n. I can write like this. So right here instead of taking from minus infinity to n terms, I will take only from minus infinity to n minus 1. Then the next term will be n. So therefore here plus x of n. So I can write like this. So this is nothing but y of n minus 1. So this is nothing but y of n minus 1. So therefore we can say, if you substitute here y of in place of n, if you substitute here n minus 1, then we are going to get sigma k is equal to minus 2. We can say n minus 1 into x of n. So therefore, this is nothing but, suppose if the summation is up to only n minus 1 means it will become y of n minus 1 bracket. So y of n is equal to y of n minus 1 plus x of n. So this is x of n. So this is x of n. So therefore we can say clearly. So y of n is nothing but y of n minus 1 plus x of n. So finally I can say in the continuous domain means it is integration. But the discrete time domain means it will become summation. So therefore y of n is equal to sigma k is equal to minus to n x of n. I have basically simplified like this, which is sigma k is equal to minus to n minus 1 x of n plus x of n. So this is nothing but y of n minus 1. So y of n is equal to y of n minus 1 plus x of n. So like this way we can write. Then the next point is delta of a into f. So delta of a into f is nothing but 1 by mod f, 1 by mod a delta of f. So just now we have discussed this formula, right? So delta of a into t. So delta of a into t just now we have discussed, which is 1 by mod a into delta of t. Where t is a dummy variable, either you can use any variable, either you can use t, either you can use x, either you can use f also. Means f is a frequency domain and t is a time domain. You can use any variable, the formula still is going to get satisfied. So delta of a t, just 1 by mod a. Delta of t, same thing. Either you can use t as a dummy variable, so you can replace t by any variable like x, f, anything. And here the concept is same. So delta of a into f is equal to 1 by mod a delta of f. So this point always you have to keep in your mind. So therefore we can say finally this concept is going to hold for any thing, because t is a dummy variable. Either you can use t, either you can use x, you can use anything. But still finally it is going to get hold. So therefore delta of a t is equal to 1 by mod a delta of t, where a can be either positive or a can be negative. I have already told you a can be positive or a can be negative also. And also I have already told you it is t is a dummy variable. We can replace t by x, or either you can replace by any variable like f also. So basically the delta of f is equal to 1 by mod a delta of f. Like t is a time domain and f is a frequency domain. So this formula is going to hold for both the time domain as well as the frequency domain. So these points always you have to keep in your mind. Now we are going to discuss the concept, which is the energy and the power in the signals. So we are going to discuss the how much amount of energy as well as the power which is going to present in the signals. So these concepts that we are going to discuss in very detail. So what is the energy formula? Energy is equal to E is equal to integration from T is equal to minus infinity to plus infinity f of t whole square into dt. So this is an important formula. Always you want to keep in the mind. So it is going to tell you this much amount of energy is going to present in the signal f of t, which is E is equal to integration from T is equal to minus infinity to plus infinity f of t whole square into dt. So this is the in the terms of the continuous time system. So E is equal to integration from T is equal to minus infinity plus infinity f of t whole square into dt. So this is the expression of the energy in the signal f of t in the continuous time domain. So f of t can be current or voltage, any real signal. So basically f of t can be any current signal or voltage signal, or it can be any real signal. So this point always you have to keep in your mind. So we can say energy is equal, the energy is going to present in any real valued signal, which is f of t. E is equal to integration from t is equal to minus infinity plus infinity f of t whole square into dt. So this point always you have to keep in your mind. So therefore we can say finally, suppose if there is any signal f of t, it's a real valued signal, either it can be a current signal or it can be a voltage signal, then the energy is going to present in the signal f of t, which is equal to E is equal to integration from t is equal to minus infinity plus infinity f of t whole square into dt. Suppose for real signal, what is going to happen? So for real signal, what is going to happen? So what's the meaning of real for energy signal? So what is the meaning of the energy signal? So for energy signal, energy is equal to finite and the power is equal to 0. So this point always you have to keep in mind. So a signal is said to be energy signal when the energy is equal to finite and the power is equal to 0. So this point always you have to keep in mind. See how you can say a signal is said to be energy signal. Suppose if you are going to find the energy in that signal, you are going to get some finite value, and if you try to figure out the power in that signal, then you are going to get 0. Then we can say the signal is said to be an energy signal. So listen carefully. Suppose some signal is there f of t. So how you can tell whether it is an energy signal or power signal? So suppose if you calculate the energy of the signal and you got a finite value, and you also calculate the power of the signal, and again you got the 0 value. So therefore we can say if these two we got, then we can say it is an energy signal. So a signal is said to be an energy signal when the energy is a finite value and the power is a 0 value. So what is the meaning of power? Power is equal to energy per time period. a time period is total time, for total time for a minus infinity to plus infinity. So energy is nothing but finite value. But total time from minus infinity to plus infinity is nothing but infinity. So finite value by infinity is equal to 0. So therefore you are going to get the power is equal to 0. So listen carefully. A signal is said to be an energy signal when its energy is equal to finite value and its power is equal to 0 value. So a signal f of t is said to be an energy signal when its energy is equal to finite value and its power is equal to 0 value. So what's the meaning of power? Power is equal to energy by time period. It's the total time. So energy, if it's a finite value, and the time is always you take the time from minus infinity to plus infinity. So definitely finite by infinity is nothing but 0. So you are going to get power is equal to 0. So finally I can say a signal f of t is said to be an energy signal when it has a finite energy and it has a 0 power. Then only we can say that signal is said to be an energy signal. Now let's go for the power signal. So a signal is said to be a power signal when if its energy is equal to infinite and its power is equal to finite. So listen carefully. A signal is said to be a power signal when its energy is equal to infinity and its power is equal to finite. So suppose if you take a periodic signal, for a periodic signal, definitely the energy is equal to infinite. But what is the power? Power is equal to total energy of the signal by total time of the signal. Means from play to infinity. So definitely, instead of calculating the energy of all the cycles, I will try to calculate the energy of only one cycle. Then I need to take only time for one cycle. So definitely here this is a finite value and this is also finite value. So definitely you are going to get a finally finite value. So therefore we can say that for a power signal, the energy is equal to infinite and the power is equal to finite. So if you see clearly that here energy is equal to finite, that is the result is called as the energy signal. Here power is equal to finite value, so that is the result is called as the power signal. So all the periodic signals are said to be power signals because for a periodic signal the energy is equal to infinity. Then what is the power? Power is equal to energy by time. Energy means the total energy of all the cycles by total time of all the cycles. Instead of calculating like this, because for every cycle the time is same and energy is same, instead of calculating for all the cycles, I'll calculate only for one cycle. So energy of one cycle by time of one cycle. So energy in one cycle is a finite value. Time in one cycle is also finite value. So if you do the ratio, again you are going to get a final value. You are going to get a finite value. So therefore we can say for a power signal, the power is equal to finite. In the case of energy signal, the energy is finite. So this point always you have to keep in your mind. So therefore we can say finally for an energy signal, the energy is a finite value and the power is equal to 0. For a power signal, the energy is equal to infinity and the power is equal to 0. So I can say in the other fashion, suppose if a signal is having if a signal is having only it is present only for finite time. If a signal f of t is present for only finite time, then we can say it is an energy signal by default because energy is finite and power is equal to 0. But if a signal is periodic signal, then we can say it's a default, it is a power signal because energy is infinity and the power is equal to 0. Power is equal to finite. So finally I can say if any signal which is having a finite duration of time, it is called as an energy signal. Then if all the periodic signals are said to be power signals, so these two important points always you have to keep in your mind. So therefore, if any signal which is present for only finite time duration, we say it's an energy signal. If all the periodic signals are said to be power signals, so these two important points always you have to keep in your mind. So finally I can say if any signal which is present only for finite time duration, it is called as an energy signal. And if all the periodic signals are if all the periodic signals are said to be power signals, so these two important points always you have to keep in your mind. Now go for the further analysis. For any signal, we can say real signals only I am going to consider. Then what is the expression of energy? Energy is equal to integration from t is equal to minus f to plus f t f of t equals to dt. So this is the expression of the energy in the signal, energy in the real value signal f of t in a continuous time domain. So basically I'm going to give these two formulas only for the continuous time domain itself only. So the energy present in the signal f of t is equal to integration from t is equal to minus into present t f of t whole square dt. Then what is the power? I've already told you power is nothing but energy by time. So limit t tends to infinity integration over one time period from minus t by 2 to t by 2 f of t whole square dt by t. So this is nothing but total energy by total time. So total, this is nothing but total energy and is a total time. So these two formulas always you have to keep in your mind. So therefore we can say, suppose f of t is a real value signal, means there is no complex term like j, and also in the continuous time domain, I am going to give the expression of the energy as well as the power. Energy is equal to energy present in the signal f of t is equal to E is equal to integration from t is equal to minus to plus t f of t whole square dt, and the power which is going to present in f of t signal, because for p is equal to limit t tends to infinity integration from minus t by 2 to t by 2 f of t whole square dt by t. So it is equal to total energy by total time. So these two important formulas always you have to keep in your mind. So finally I can say, suppose if f of t is a real value signal without any complex term, then for the continuous time domain, I am going to give the expression of the energy present in the signal and the power present in the signal. So E is equal to integration from t is equal to minus into plus t f of t whole square dt, and power is equal to a limit t tends to infinity integration from minus t by 2 to t by 2 f of t whole square dt by t, which is equal to total energy by total time. So these two important formulas always you have to keep in your mind. So now let's go for the other important point, which is for real as well as the complex signals. So now I am going to give the expression for both the real values as well as the complex value signals. I am going to give the general expression. So whenever f of t is there, replace f of t by mod of f of t, that's it. So replace f of t by mod of f of t, then you are going to get the expression for the complex value signals. So modulus means, suppose if you take the real value signals, modulus means same f of t only. But in the case of complex value signals, mod of f of t means, suppose if f of t is equal to a plus ib, f of t is equal to a plus ib, then what is the modulus of the f of t? So modulus of f of t is equal to under root over a square plus b square. So this we are going to consider. So listen carefully. See, I have already given the expression of the energy and the power for a real value signals. So now I am going to give the general expression for both the real value signals as well as the complex value signals for the energy as well as the power. So just replace f of t by mod of f of t, that's it. So therefore, the energy present in the signal is equal to, the energy present in the signal f of t is equal to integration from t is equal to minus to plus t mod of f of t whole square dt, and power is equal to limit t tends to infinity integration from t is equal to minus t by 2 to plus t by 2 mod of f of t whole square dt by t. So these things always you have to keep in your mind. So therefore we can say these points always you have to keep in your mind. Suppose if you are going to calculate for periodic signals, I have already told you for periodic signals, no need to calculate from t is equal to minus to plus infinity. Just to go for only one cycle, which is integration from t is equal to we can say one time period. T is equal to t f of t whole square dt by mod of f of t whole square dt by capital T. Only for periodic signals. Instead of calculating the energy and time for all the cycles, I will calculate only for one cycle in the case of periodic signals. So P is equal to integration from T is equal to capital T f of t mod of f of t whole square dt by capital T. So this is what you can say. Here also you can use mod of f of t. So mod of f of t, general expression, right? So let's go for the general expression only we are going to take. So general expression only we are going to take. So what I have told you, whether it is a complex signal or whether it is a real value signal, just to replace f of t by mod of f of t, then this formula is valid for both the real value signals as well as the complex value signals. Just we have kept the modulus value, that's it. So therefore we can say these expressions are going to hold for the real value signals as well as the complex value signals in the case of continuous time domain. In the case of continuous time domain, so you can see energy is equal to integration from t is equal to minus 1 to plus infinity mod of f of t whole square dt, and the power is equal to limit t tends to infinity integration from t is equal to minus t by 2 to plus t by 2 f of mod of f of t whole square dt by capital T. So suppose if you are going to calculate the power for periodic signals, then instead of calculating energy for all the cycles and time for all the cycles, I will try to find only for one cycle. So therefore we can say integration from t is equal p is equal to integration from t is equal to 0 to capital T f mod of f of t whole square dt by capital T. So these things always you have to keep in mind. Now for the discrete time domain, I am going to give the formulas for the energy and power. So for real and the complex signals, in the case of discrete time domain, I am going to give the general expression, which is the energy present in the signal f of n. Here f of n, because it's a discrete time domain, either it can be a real value signal or either it can be a complex value signal, which is E is equal to sigma n is equal to minus n to plus n t mod of f of n whole square, and power is equal to limit n tends to infinity sigma n is equal to minus n to plus n mod of f of n whole square by, here how many samples are there? From minus n to plus n we have 2n plus 1 samples are there, because at 0 also one sample is there, so we need to add all the samples. So we are going to get finally 2n plus 1 samples, because from minus n to minus 1 we have n samples, from 1 to n we have n samples, at 0 we have 1 sample, so total number of samples are 2n plus 1. So that is the reason I have taken 2n plus 1 number of samples. Suppose if you want to write the expression for periodic signal, so instead of calculating the energy and time for all the cycles, I'll calculate only for one cycle. So therefore sigma n is equal to 0 to n minus 1 mod of f of n whole square. From 0 to n minus n1 we have total n samples are there. N samples are because the period of the signal is capital N. So by capital N, because the number of samples are only n. So these point always you have to keep in your mind. So you have to remember the formulas for both the continuous time domain as well as the discrete time domain. So I am going to give the expression of the amount of energy present in the discrete time domain, the amount of power which is present in the continuous time domain. See, basically this formula always you have to keep in your mind. So I am going to give the expression of the energy. So basically I am going to give the expression of the energy as well as the power which is going to present in the discrete time signals. These signals can be the real value signals or complex value signals. E is equal to sigma, n is equal to minus n to plus infinity mod of f of n whole square, and power is equal to limit n tends to capital N tends to infinity sigma minus n to n f of mod of f of n whole square by 2n plus 1. And if you want to find the power for periodic signal, then we can say P is equal to, which is sigma n is equal to 0 to n minus 1 mod of f of n whole square by n for periodic signals. So finally I am going to do a revision of these two formulas. Definitely you have to remember. So finally I am going to give the expression of the energy as the power for the continuous time domain signals, whether it can be real value signal or the complex value signals, which is E is equal to integration from t is equal to minus 50 plus of t mod of f of t whole square dt, and power is equal to limit t tends to infinity integration from t is equal to minus t by 2 to plus t by 2 mod of f of t whole square dt by capital T. Suppose if you are going to find the for the periodic signals, power for periodic signals, instead of finding the energy for each cycle and time for each cycles, I will calculate only for energy for one cycle and time for one cycle. Then we are going to get P is equal to, which is integration from t is equal to 0 to capital T f of t whole square mod of f of t whole square dt by capital T for periodic signals. Suppose similarly I am going to give the expression of the energy and the power which are present in the discrete time signals. These signals can be the real value signals or complex value signals, which is E is equal to sigma, n is equal to minus 70 plus 70 mod of f of n whole square, and power is equal to limit n tends to infinity sigma n is equal to minus n to plus n mod of f of n whole square by 2n plus 1, because the number of samples which are present from minus n to n are 2n plus 1, because from minus n to 1 to minus 1 we have n samples, and from 1 to n we have n samples, at 0 we have other samples, so total number of samples are 2n plus 1. So that is the reason you have taken 2n plus 1. Suppose if you calculate the power for a periodic signal, so instead of finding the power for each and every cycle, energy for each and every cycle and time for each and every cycle, I calculate the energy for only one cycle and time for only one cycle. Then I am going to get P is equal to sigma n is equal to 0 to n minus 1 mod of f of n whole square by n, because from n is equal to 0 to n minus 1 we have n number of samples, because the signal f of n is a periodic signal of only n sequence. So take here n only. So this is for the periodic signal. So here f of n is having a periodic signal, is having a period of capital N. So these things always you have to keep in your mind. So if you remember these formulas, you can solve the energy and the power for any signals in an easy amount of time. So these things always you have to keep in your mind. Now we are going to discuss some more concept, which is the energy and the power of different signals. So basically now I am going to discuss different type of signals. So for those signals, I am going to tell you what is the corresponding energy as well as the corresponding power. So you can see the first signal, here f of t is equal to a. So we can say it's a constant signal. Its angle is equal to a for all the time. So definitely we can say its energy is equal to infinity and its power is equal to a square. So these two formulas we have to remember. So for a constant signal f of t is equal to a, its energy is equal to infinity and the power is equal to a square. So this point always you have to keep in your mind. So for a signal f of t is equal to a, it is having a constant amplitude of a for all the time. It's a constant signal and its amplitude is equal to a for all the time and its energy is equal to infinity and the power is equal to a. Power is equal to a square. Power is equal to a square. See, basically if you want the how you got this one, they can apply the formulas and you are going to get this result. So I have given the final results. But if you want the detailed explanation means you can apply these formulas and you can simplify. Finally we are going to get this one. So for the signal f of t is equal to a, its energy is equal to infinity and the power is equal to a square. So if a signal f of t is having a constant magnitude a for all the time from minus infinity to plus infinity, we can say this signal is having energy which is equal to infinity and the power is equal to a square. So now the other signal f of t is equal to b into u of t. So we can say the step signal of having a magnitude b. So for t less than 0, its magnitude is equal to 0 and for t greater than or equal to 0, its magnitude is equal to b. So for this signal, what is the energy? Energy is equal to infinity and power is equal to b square by 2. So b square by 2. So here E is equal to infinity and P is equal to b square by 2. So these things always you have to keep in your mind. So therefore we can say that here energy is equal to infinity and the power is equal to b square by 2. B square by 2. So these point always you have to keep in your mind. So for a signal f of t is equal to b into u of t, we can say its energy is equal to infinity and the power is equal to b square by 2. B square by 2, because if you see this is a for all the time and it's b only for t greater than 0. So the signal is half of this previous signal. So its power is also half of the previous signal, which is b square by 2. So now there is a signal f of t is equal to a into sine omega t. A into sine omega t. So it's a periodic signal, right? So I've already told you periodic signals are power signals. So their energy is equal to infinity and power is equal to finite. Its value is equal to a square by 2. So remember RMS value whole square. What is shortcut to remember? RMS value of the periodic signal whole square. So what is the RMS value of the periodic signal? A by root 2. Then just to the square of that term. So we are going to get this value is equal to a square by 2. So for a periodic signal, what is the power? RMS value whole square. RMS value is a by root 2. Just to the square of this one, we are going to get a square by 2. So now these are the for continuous time. So let's go for the discrete time. See, f of n is equal to a into u of n. So this is in this format. So energy is equal to infinity and power is equal to a square by 2. Same as this concept. So this is for the continuous time and this is for the discrete time. So therefore energy is equal to infinity and power is equal to a square by 2. So these things always you have to keep in your mind. So these four formulas always you have to keep in your mind. So first signal, second signal, third signal, fourth signal. All these four signals, we have to remember the energy as well as the power. So definitely in examinations, at least from a question form, will be coming from this concept. So I recommend you to remember this thing. See, I've already told you what is the energy signal. Energy signal means I've already told you energy is equal to finite. Energy is equal to finite. And the power is equal to, we can say, so for an energy signal, the energy is equal to finite and power is equal to 0. Then only we say it is an energy signal. And for a power signal, energy is equal to infinity and power is equal to finite. Then we say it is a power signal. So from this, what is the first signal? Energy is equal to infinity and power is equal to finite. So it is going to satisfy this condition. Second case, so energy is equal to infinity and power is equal to finite. So therefore we can say this is the power signal. This is the power signal. Let's go for the second case. F of t is equal to b into u of t. Where energy is equal to infinity and power is equal to finite. So this is also power signal. Now let's go for the third signal. F of t is equal to a into sine omega t. So here also energy is equal to infinity and power is equal to finite. So this is also a power signal. So this is also power signal. So finally, f of n is equal to a into u of n. Here energy is equal to infinity and power is equal to finite. So this is also a power signal. So therefore, all the signals that we have discussed, all are the power signals. So finally, I can say that a signal is said to be energy signal when it is having energy is equal to finite and power is equal to 0. A signal is said to be a power signal if its energy is equal to infinity and power is equal to finite. So for all the signals, I am going to discuss what is the energy as well as the power, which is going to also with this each and every signal we are going to discuss. Suppose the signal f of t is equal to a. So from minus infinity to plus infinity, the signal is having a magnitude of a for all the time. Then its energy is equal to infinity and power is equal to a square power and power is equal to a square. So we can see its energy is equal to finite. Its energy is equal to infinity and power is equal to finite. So the signal is called as a power signal. For the other signal, f of t is equal to b into u of t. So for t less than 0, its value is equal to 0, and for t equal to 0, its value is equal to b. So this is half of the previous signal. So its energy is equal to infinity and power is equal to b square by 2. So half of the previous signal power. So as you can see clearly, energy is equal to infinity and power is equal to finite. So the signal is also a power signal. Now let's go for the other signal, f of t is equal to a into sin omega t. So this is a periodic signal. So I've already told you for periodic signal, the energy is equal to infinity and power is equal to RMS value whole square. RMS value is a by root 2. Do a square of that one, we are going to do a square by 2. So you can see energy is equal to infinity and power is equal to finite. So this is a power signal. So finally, some discrete time signal f of n is equal to into u of n. So this is same as this signal. So energy is equal to infinity and power is equal to a square by 2. A square by 2. So you can see energy is equal to infinity and power is equal to finite. So this also comes under the power signal. So all the signals I have discussed, they belong to which category, whether they are energy signal, power signal, and also I have given the what is the energies contained in that signal and power is going to contain in this signal. All these things I have discussed in a very detailed manner. So now let's go for the another thing regarding some formulas. So I am going to discuss some important formulas. These formulas always you have to keep in your mind. Suppose f of t is an energy signal. Suppose if f of t is an energy signal, then I am going to represent f of t as a summation of the even signal plus odd signal. So I have already told you, take any signal, any real signal, I can represent in the summation of the even signal as well as the odd signal as I have already told you. So therefore, here f of t is equal to f e of t plus f naught of t, where this is the even part of the signal and this is the odd part of the signal. Then if you try to figure out the energy contained in the f of t, it is equal to energy contained in the even signal plus energy contained in the odd signal. So this formula always you have to keep in your mind. So basically f of t is a energy signal. F of t is a energy signal. So this f of t signal, any random signal, I can represent the summation of even signal plus odd signal. So f of t is equal to f of t plus f naught of t. So if you want to find the energy in the signal f of t, which is equal to energy present in the even part of signal plus energy present in the odd part of signal. So try to find what is the energy present in the even part of signal and try to find the energy present in the odd part of the signal, and do the addition of these two things in order to get the overall energy present in the f of t signal. So this concept always you have to keep in your mind. Sometimes it is difficult to find the energy present in the f of t. So then what we will do, we will convert into even part as well as the odd part, and then we will try to find the energy present in the even part of the signal, and we also try to find the energy present in the odd part of the signal, and we will add these two things in order to get the energy present in the f of t signal. So finally, suppose if f of t is an energy signal, and I have already told you any signal can be represented as summation of the even part of the signal plus odd part of the signal. Then if you want to find what is the energy present in f of t, which is equal to energy present in the even part of the signal plus energy present in the odd part of the signal. So E is equal to E plus E naught. Now let's go for the other point, which is suppose if f of t is a power signal. So if the f of t is a power signal, I have already told you any signal we can represent in summation of the even part of the signal plus odd part of the signal. So f of t is equal to f e of t plus f naught of t. So any signal I can represent in summation of the even part of the signal plus odd part of the signal. So if you want to calculate what is the power which is going to present in f of t, which is equal to power present in the even part of the signal plus power present in the odd part of the signal. So same concept, same as the previous case, whether it is an energy signal or whether it is a power signal, this concept is going to hold. So therefore we can say if f of t is an energy signal or power signal, that signal we can represent in summation of the even part of the signal plus odd part of the signal, in the corresponding energy of the f of t is equal to energy present in the even part of the signal plus energy present in the output signal. Similarly, the power present in the f of t is nothing but the power present in the even part of the signal plus the power present in the output of the signal. So these concepts always you have to keep in your mind. So now let's go for the another point. Suppose if f of t is a summation or the subtraction of two signals f1 of t and f2 of t. So here f of t is summation of two random signals f1 of t and f2 of t. Summation or subtraction. Then the overall energy present in the f of t is nothing but e1 plus e2 plus or minus 2 into integration of t is equal to minus f plus t f1 of t into f2 of t dt. So basically, what is the meaning of energy? You know the formula E is equal to integration from t is equal to minus f plus f of t whole square dt. So f of t is nothing but f1 of t plus or minus f2 of t. Apply this formula and if you simplify, finally we are going to get the overall energy containing f of t is equal to e1 plus e2 plus or minus 2 into integration from t is equal to minus f2 plus infinity f1 of t into f2 of t into dt. So this is the thing just now we have discussed. See what is the meaning of energy in the signal f of t? So E is equal to integration from t is equal to minus f2 plus infinity f of t whole square dt. So here f of t is equal to f1 of t plus or minus f2 of t. Just substitute and do the square of this one. So finally if you simplify, we are going to get E is equal to e1 plus e2 plus or minus 2 into integration from t is equal to minus f2 plus infinity f1 of t into f2 of t into dt. So this point always you have to keep in your mind. So finally I can say the overall energy present in the signal f of t is equal to e1 plus e2 plus or minus 2 into integration from t is equal to minus f2 plus infinity f1 of t into f2 of t into dt. So this point always you have to keep in your mind. So finally I can say if you take any signal and if you want to represent the signal as a summation and subtraction of two random signals f1 of t and f2 of t, then the overall energy present in the f of t is equal to e1 plus e2 plus or minus 2 into integration from t is equal to minus f2 plus f f1 of t into f2 of t into dt. Here e1 is the energy present in the signal f1 of t and e2 is the energy present in the signal f2 of t. So these things always you have to keep in your mind. So now the another point is, suppose if f1 of t is a power signal and f2 of t is a power signal. So here f1 of t is a power signal and f2 of t is also power signal. Then I have taken a random signal f1 of t. I have represented in a summation and subtraction of these signals f1 of t plus or minus f2 of t. Then what is the overall power? So basically these are power signals. So the second signal is also power signal. If f1 of t is a power signal and f2 of t is a power signal, the summation or subtraction always going to give you another power signal only. Then if you want to find what is the overall power present in f of t, which is equal to p1 plus p2 plus or minus 2 into under root over p1 p2. So p is equal to p1 plus p2 plus or minus 2 into under root over p1 p2. So this point always you have to keep in your mind. So therefore we can say p is equal to p1 plus p2 plus or minus 2 into under root over p1 p2. So if I say here in this concept also f1 of t is a energy signal, f2 of t is also energy signal. So similarly if you do the additional subtraction of these two energy signals, again we are going to get the overall energy signal only. f1 of t is energy signal, f2 of t is also energy signal. So either you do subtraction or either you do addition, finally you are going to get the energy signal only. So therefore here we can say that f1 is a energy signal and f2 is an energy signal. So definitely f of t is also energy signal. So for this one, so like this it is going to be told. And for this signal, so you can see f of t is equal to f1 of t plus or minus f2 of t. Suppose if f1 of t is a power signal and f2 of t is a power signal, then we can say that the f of t signal is also power signal. So the net power present in f of t is equal to p1 plus p2 plus or minus 2 into under root over p1 p2. So p is equal to p1 plus p2 plus or minus 2 into under root over p1 p2. So this point always you have to keep in your mind. So therefore we can say that finally here f1 of t is a power signal and f2 of t is also power signal. And if you take a, so either you do the addition or either you do the subtraction, the overall signal is again a power signal. And if you want to find the power in the signal, p is equal to p1 plus p2 plus or minus 2 into under root over p1 p2. There plus means there plus, if it is minus means there also minus. Similar here also this plus means plus here, if it is minus means here also minus. So this is what I am trying to tell you. So therefore, finally, I can say the combination of these two concepts, I can tell you like this. Suppose if F1 of t is a energy signal and F2 of t is also an energy signal, either you are doing a addition or either you are doing subtraction, the resultant is also energy signal. And if you want to find what is the overall energy present in F of t, which is equal to E1 plus E2, plus or minus 2 into integration from t is equal to minus 1 to plus 70, F1 of t into F2 of t into dt. Similarly, if F1 of t is a power signal and F2 of t is a power signal, either you are doing addition or subtraction, the resultant signal is also power signal. And if you want to find what is the overall power present in F of t, then P is equal to P1 plus P2 plus or minus 2 into under root over P1, P2, where P1 is the power present in F1 of t and P2 is the power present in the F2 of t. So these things always you have to keep in your mind. So now let's go for the another concept, which is suppose for any real signal, I've already told for any real signal, just now we have discussed, any real signal can be represented by summation of given signal plus odd signal. So any signal f of t, I can represent as a summation of the even signal as well as the odd signal. So f of t is called f of t plus f naught of t. So I've already told you any even signal, any real signal can be represented as summation of the even signal as well as the odd signal. And if you want the even signal, I've already told you how to get the even part of the signal. F of t is equal to f of t plus f of minus t by 2. I've already told you. Suppose if you want the odd part of the signal, then which is f of t minus f of minus t by 2. So these things always you have to keep in your mind. So any signal, any real signal f of t, I can write as summation of the even signal as well as the odd signal. So f of t is equal to f of t plus f naught of t. Then integration from t is equal to minus f to plus of t, f of t into f naught of t, which is equal to 0, Why it is like this? Why it is like this is very simple, because we can say clearly what is going to happen here, because even signal to odd signal is again equal to odd signal. I have already told you, whenever you multiply even signal and odd signal, the result signal is an odd signal. So you are doing from t is equal to minus f to plus f t. So plus area and minus area are going to get cancelled. So finally you are going to get its value is equal to 0. So therefore we can say f of t and f naught of t are also called as the orthogonal signals if they satisfy this condition. So integration from t is equal to minus f to plus f t, f of t into f naught of t dt is equal to 0. So whenever the two signals are satisfying these two property, then we can say these signals are orthogonal signals. So therefore f of t and f naught of t are called as the orthogonal signals. So whenever you multiply two signals and do the integration from t is equal to minus f to plus f t, if the integration is equal to 0, then we can say those signals are called as the orthogonal signals. So that is the reason here, if you see basically here f of t is a power signal. So for f of t, I will get f of t plus f naught of t, I already did. So basically for this one, let me do for this one. Here f of t is called f of t plus f naught of t. So here, if you want to find the net energy, what it will be here, E plus E naught plus, there will be another thing, 2 into integration from t is equal to minus f to plus f t, here f of t into f naught of t into dt. So this part we are going to get. But I have already told you this part is equal to 0. So this part is equal to 0. So because even to odd signal is equal to odd signal. So if you do integration from t is equal to minus f to plus f t, again it is going to become 0. So this part is neglected. If this part is become 0 means we can remove this one. That is the reason I have written the overall energy is equal to E plus E naught, because I have removed this part. So this is what I am trying to tell you. So therefore we can say any signal I can represent in the formation of the summation of the even signal as well as the odd signal. And if you want to find the overall energy, present in the f of t, then it is equal to energy present in the even part of signal plus energy present in the odd part of signal, plus there will be some extra factor, which is 2 into integration from t is equal to minus f plus f t, f of t into f naught of t dt. But this value is equal to 0. So definitely this extra part is removed. That is the reason I have not written this extra part. So this part is equal to 0. So if you multiply any two signals and if you do integration from t is equal to minus f to plus f t, and if the value is equal to 0, then those two signals are called as the orthogonal signals. And this property is satisfied by even part of signal as well as the odd part of signal. So these two signals are called as the orthogonal signals. So now let's go for the other point, which is for all power signals. So for all power signals, here basically I have taken all the signals are power signals. All these are power signals. Either you do subtraction or either do addition. Finally, you are going to get the result signal is also power signal. So f of t is called f1 of t plus or minus f2 of t plus or minus f3 of t plus or minus up to plus or minus fn of t. And each signal is a power signal and also orthogonal. So basically, I can say, and each signal is a power signal and also orthogonal. Then what is the overall power? Overall power is the P1 plus P2 up to Pn. So we can say that finally, so we can say that here we can say, suppose all the signals are power signals, all the signals are power signals, all the signals are power signals, and all the signals are also orthogonal, then we can say, see, these two conditions are to satisfy. So all the signals are power signals and also all the signals are orthogonal signals. Then we can say the net power present in the f of t is the summation of the individual power present in each and every signal, which is P is equal to P1 plus P2 plus up to Pn. So this point always you have to keep in your mind. So this point always you have to keep in your mind. So therefore we can say that if you take f of t, which is a summation of the subtraction of so many power signals, then these signals are power signals as well as the orthogonal signals. Then we can say that the net power present in f of t is the summation of the individual power present in each and every signal. So P is equal to P1 plus P2 plus up to plus Pn. So this point always you have to keep in your mind. So now let's go for the another concept, which is the complex signals. So for complex signals, if integration from P1 to P2, f1 of t into f2 of t conjugate if it is equal to 0, and when f1 of t and f2 of t are complex signals, then they satisfy that condition. Then if they satisfy that condition, then these are called as the orthogonal signals in the range P1 to P2. Here I should write then if. So if here, so if you see, I already told you for the real signals, what is the property of orthogonal? Just multiply the two signals and the integration from t is equal to minus 7 to plus 70. If this value is equal to 0, then we can say those two signals are called as the orthogonal signals, right? Suppose, what is the condition for the orthogonal signals for the complex signals? Here f1 of t is a complex signal and f2 of t is also complex signal. Then what is the condition is integration from T1 to T2, f1 of t into f2 of t conjugate. If its value is equal to 0, we can say that these two signals are called as the orthogonal signals in the range from T1 to T2. Here f1 of t is a complex signal and f2 of t is also complex signal. And if they are going to satisfy this condition, which is integration from T1 to T2, f1 of t into f2 of t conjugate, if its value is equal to 0, then we can say these two complex signals are orthogonal in the range from T1 to T2. So this is the definition for the complex signals. But if you want the definition for real signals, just remove this conjugate, and in place of T1 which is minus infinity, and in place of T2 which is plus infinity. That's it. So this point always you have to keep in mind. So we can say the definition of the orthogonal signals for the complex signal says basically integration from T1 to T2, f1 of t into f2 of t conjugate is equal to 0. So here f1 of t is a complex signal and f2 of t is also complex signal. And if they are going to satisfy this condition, then we can say these two complex signals are orthogonal in the range from T1 to T2. So this point always you have to keep in your mind. So now the next point is for orthogonal signals. For orthogonal signals, if integration from T1 to T2, f1 of t into f2 of t dt, if it is equal to 0, then f1 of t and f2 of t are orthogonal signals in the range from T1 to T2. So we can give in a general range also. Either for the real signals or either for the complex signals, you can give the general range here. Here, f1 of t and f2 of t is the real signals, but if you keep your conjugate, then these are called as the complex signals. So we can say if the integration from T1 to T2, f1 of t and f2 of t dt is equal to 0, then we can say the f1 of t and f2 of t are called as the orthogonal signals in the range from T1 to T2. So this is the condition for the real signals. And if you want the condition for complex signals, means here keep your conjugate. That's it. So remaining everything is same. Here, if f1 of t, f2 of t, up to f1 of t are orthogonal signals in the range from minus 50 to plus 50, and also all are energy signals, then so what they are given basically here all the signals are energy signals and all the signals are orthogonal signals. then I have to be summation as well as subtraction of these different signals. Then I got in a signal f of t. Then what is the overall energy present in the signal f of t is nothing but energy present in each and every signal. That's it. Summation of each and every energy present in each and every signal, which is E1 plus E2 up to En. So this point always you have to keep in mind. Same thing is going to hold for the power also. Here if f1 of t, f2 of t, if all the signals are power signals and if all the signals are orthogonal signals, then the coordinate signal f of t is nothing but the summation of the individual power present in each and every signal. Or you can say if all the signals are the energy signals and if all the signals are orthogonal signals, if these two conditions are satisfied, then the net energy in f of t is nothing but summation of the energy present in each and every signal. So finally, I can say only one point. Suppose if you take all the energy signals and all these are orthogonal, then either you do subtraction or either you addition in different manner. Finally, the resultant signal energy is nothing but summation of the individual signal energy. Similarly, if you take all the signals of power signals and also all these orthogonal signals and we do in whichever the addition or subtraction you do, then you are going to get the net resultant signal f of t. For that, the net power is a summation of the individual signal power. So this is what I am trying to tell you. So this is the concept that you always have to keep in your mind. So now the last thing is here, suppose f of t is equal to a into cos omega t. So I have already told you this is also periodic signal, right? So this is a periodic signal. So for a periodic signal, what is the, see, this is basically periodic signal. So all the periodic signals are power signals. I have already told you. So all the periodic signals are power signals. So definitely the energy is equal to D and power is equal to RMS value whole square. RMS value is a by root 2. So do the square of that one, we are going to get a square by 2. So whether it is a sin omega t or a cos omega t, the energy and power are same. So or I can keep it or also whether it is a cos omega t or a p right here or so I can write here, right? So let me keep it in here. So now I can write like this or a sin omega t. So definitely we can say all these are power signals. All these are periodic signals. So all the periodic signals are power signals. So definitely the energy is equal to infinity and power is equal to RMS value whole square. RMS value is a by root 2. So with the square of that one we are going to get a square by 2. So these formulas definitely we have to remember in order to solve the numericals. So these concepts always you have to keep in your mind. Now we'll discuss another thing which is about the some formulas we are going to discuss, which is cos h of 80 is equal to half of a to the power of 80 plus a to the power of minus 80. So generally I used to write like this. Generally I used to remember like this, which is equal to a to the power of 80 plus a to the power of minus 80 by 2. And for sin h of 80 is nothing but a to the power of 80 minus e to the power of minus 80 by 2. So these two things always you have to keep in your mind. Therefore, sin h of 80 is equal to e to the power of 80 plus e to the power of 80 minus e to the power of minus 80 by 2. And cos h of 80 is equal to e to the power of 80 plus e to the power of minus 80 by 2. So these two important formulas always you have to keep in your mind, which is sin h of 80 is equal to e to the power of 80 minus e to the power of minus 80 by 2. And cos h of 80 is equal to e to the power of 80 plus e to the power of minus 80 by 2. Sin means negative, cos means positive. So this is the same thing. I don't have to tell more about this one. H means hyperbolic. So sin h of 80 is nothing but e to the power of 80 minus e to the power of minus 80 by 2. And cos h of 80 is equal to e to the power of 80 plus e to the power of minus 80 by 2. So these two formulas always you have to keep in mind. And sin means negative, cos means positive, and h means hyperbolic. So therefore finally I can say sin h of 80 is equal to e to the power of 80 minus e to the power of minus 80 by 2. And cos h of 80 is equal to e to the power of 80 plus e to the power of minus 80 by 2. The next thing is the summation of the geometric series. Because this is a very, very important thing. Definitely this concept is there in the calculation of the signal system. So that is the reason I have written this geometric series expression a plus ar plus ar square up to a into r to the power of n. That summation is equal to a into 1 minus r to the power of n plus 1 by 1 minus r. Here a is the first term. Here r is the this is the value that we are going to multiply for each and every term. Here number of terms are here 1, 2 up to n plus 1. So the number of terms are n plus 1. So n plus 1. So here a is the first term, r is the, so by this number we are going to multiply each and every term. Then the total number of terms in this expression are n plus 1. Here it is starting from 1, right? So r the power a into r the power of 1 plus a into r square, like that up to e to the power of n. So there are n plus 1, so n plus 1 terms. So always remember a plus ar plus ar square up to a into r the power of n, then it is equal to a into 1 minus r the power of n plus 1 by 1 minus r. A is the first term, r is nothing but by this factor each and every term is going to get multiplied. Then in the n plus 1 is nothing but total number of terms which are present in this expression. So this is a formula always you have to keep in your mind. So a plus ar square up to a into r the power of n, which is equal to a into 1 minus r all the power of n plus 1 by 1 minus r. A is the first term, r means by this factor each and every term is going to get multiplied, and the total number of terms which are present in this expression is n plus 1. So this I have used here. So the first number is the first number into 1 minus, by this factor each and every term is going to get multiplied, and this n plus 1 is nothing but total number of terms represented in this expression, which is n plus 1. So these things always you have to keep in your mind. So these three formulas are very much important in the signal and systems. That is the reason I have written like this. So now we are going to discuss another important concept, which is the types of the signals. So now I am going to discuss the different types of nature of the signals. So different types of nature of the signals. So you have to know which signal is going to represent which thing, and you always have to keep in your mind. So we are going to discuss about the types of the signals. The first one is the even signal or the symmetric signal. Even signal or symmetric signal. So what is the meaning of this one? Even signal means I already told you, when f of t is equal to f of minus t, we say this signal is said to be even signal or symmetric signal, means it is symmetric with respect to y-axis. So all the signals are basically real signals. What are the concept that I am going to tell you? It is all about the real signals only. So therefore we can say a signal is said to be even signal or symmetric signal when f of t is equal to f of minus t. F of t is equal to f of minus t. This we can say it is symmetric with respect to y-axis. Then odd signal or the anti-symmetric signal. What is the meaning of this one? When f of t is equal to minus of f of minus t, or simply we can say f of minus t is equal to minus of f of t, then we can say it is a odd signal or the anti-symmetric signal. So I want to find what is the value of this function at t is equal to 0. To substitute here in place of t 0, f of 0 is equal to minus of f of minus 0. Minus 0, there is nothing like minus 0. So therefore it will become minus of f of 0 only. So because there is nothing like minus 0, so minus 0 is nothing but 0. So take this, the LHS we are going to get f of 0 plus f of 0 is equal to 0. So f of 0 plus f of 0 is 2 into f of 0. So 2 into f of 0 is equal to 0 means definitely f of 0 is equal to 0. So therefore we can say that I have already proved here. So therefore we can say for odd signal and anti-symmetric signal, we can say f of minus t is equal to minus of f of t, or we can also say that f of 0 is always equal to 0, means at f of 0 means at t is equal to 0, that signal should always have 0 value only. So at t is equal to 0, that signal should have always 0 value only for a odd symmetric, or you can say odd signal. So therefore we can say for odd signal or the anti-symmetric signal, f of minus t is equal to minus of f of t, and f of 0 is always equal to 0. Because I have already proved you like if t is equal to 0, and if we simplify, finally we got f of 0 is equal to 0. So definitely we can say the signal is said to be odd signal or anti-symmetric signal with respect to the axis, where f of minus t is equal to minus of f of t, and f of 0 is always equal to 0. So this point always you have to keep in your mind. So now let's go for another thing, which is a periodic signal. So what's the meaning of periodic signal? After a certain time period, the signal is going to repeat its waveform. So after a certain period, the signal is going to repeat its waveform, then that is called as a periodic signal. So listen carefully. What is the meaning of periodic signal? After a certain time period, the signal is going to repeat its nature, then that is called as a periodic signal. So f of t plus or minus kt is equal to f of t. F of t plus or minus kt is equal to f of t, where k is an integer. K is always an integer. K is always an integer means we can say plus or minus 1, plus or minus 2, plus or minus 3, like that. It's always an integer, and t is the time period. So f of t plus or minus kt is equal to f of t, where k is an integer, which is integer means plus or minus 1, plus or minus 2, plus or minus 3, like that, and t is the time period, means the signal is going to repeat its own waveform. So that is the thing always you have to keep in your mind. So f of t plus or minus kt is equal to f of t, where k is an integer and t is the time period of the signal. So this concept always you have to keep in mind. So therefore we can say a signal is said to be periodic signal means a signal is going to repeat its waveform after a certain time period. So what is the general representation? F of t plus or minus kt is equal to f of t, where k is called as the integer, which is plus or minus 1 plus or minus 2, and t is the time period. So let's go for the different things here. So you can see for sin t and for cos t and e to the power of jt, the time period t is equal to 2 pi. So sin t is nothing but for sin t, what's the time period? 2 pi, and for cos t, the time period is 2 pi, and for e to the power of jt, the time period is 2 pi. So what is the meaning of this one? See, just in substitute t plus 2 pi, and what you are going to get? Sin of t plus 2 pi is nothing but sin t. Similarly, cos of t plus 2 pi is nothing but cos t. Similarly, e to the power of j, t plus 2 pi. So if you simplify, we are going to get again e to the power of jt. So therefore, what is time period? T is equal to 2 pi. So therefore, for sin t, the time period is 2 pi, and for cos t, the time period is 2 pi, and for e to the power of jt, the time period is 2 pi. Suppose for sin of omega t and cos of omega t, for e to the power of j of omega t, what is the time period? I already told you, for these signals, the time period is 2 pi. Suppose it is 2 pi, and for these signals, what is the time period? I already told you. Suppose for the signal f of t, if its time period is t, and for signal f of jt, I already told you just by the conversion, I already told you by the conversion. This is whenever you are going to multiply at, either you are expanding the signal or either you are converting the signal. So divide by a, I already told you. So your time period will become t by a. So just divide by omega here. So 2 pi by omega. So 2 pi by omega. So listen carefully. If f of t is time period t, then f of a t. Here, if a is greater than 1, it is compressing the signal. If a is less than 1, it is expanding the signal. So therefore, for the time period, just I already told you, for f of a t, for the f of t signal endpoints, just divide by a, then we are going to get the new signal endpoints. So previous signal time period is t, so the new signal time period is divide by a, we are going to get t by j. So in this case, sin t, cos t and e to the power of jt, the time period is 2 pi, and for sin of omega t and cos of omega t and e to the power of j into omega t, the time period is 2 pi by omega. Then e to the power of jt, you can write like this: cos theta plus j sin theta, or you can also write 1 at an angle of theta because its magnitude value is equal to 1 and angle theta is theta. So you can write in different ways. E to the power of jt is equal to cos theta plus j sin theta, or you can say 1 at an angle of theta because what is the magnitude, which is 1, and what is the angle? Angle is nothing but theta you are going to get. So this is the way of writing in different format. So this is the you can say rectangular format, this is the polar format, and this is the exponential format. So in different ways we can write like this: e to the power of jt is equal to cos theta plus j sin theta is equal to 1 at an angle of theta. So this is for the continuous case nature. Let's go for the discrete nature. Then f of n plus capital is equal to f of n. Then we can say it is a periodic signal. So even f of n plus or minus n, either you can use plus n or either you can use minus n, concept is same. So either you can use plus or minus, the concept is same. So f of n plus or minus n is equal to f of n. Then the signal f of n is said to be a periodic signal. So f of n plus or minus n is equal to f of n. Then we can say that signal is said to be a periodic signal. So f of n plus or minus n, if it is equal to f of n, then we can say that signal is said to be a periodic signal. Because this is for the discrete nature. Either you can use a some factor k also we can use, right? Isn't it free? I can write general expression like this also I can use. So same as the previous cases, plus or minus k into n, I can write like this also, which is equal to f of n. Here k is a integer, just plus or minus 1, plus or minus 2 like that, and n is the time period of this discrete moment. Where n is called as the number of distinct samples, or you can say time period, and it always an integer. So because in the case of discrete time, always we are taking only the integer values 1, 2, so definitely it will be integer value only. So n is nothing but number of distinct samples, or we can also say time period, or we can also say it is a basically an integer. So n is nothing but number of distinct samples. So simply we say the time period. Basically it is always an integer number. It is always an integer. So finally I can say n is nothing but number of distinct samples. It is also called as a time period, and it always an integer. So here for e to the power of jn and sin n and cos n, what the time period is nothing but 2 pi, 2 pi. So listen carefully. Here I have not done some important point. So for sin n, cos n, and e to the power of j n. Now what is the time period? The time period is nothing but the time period is equal to 2 pi. Time period is equal to 2 pi. 2 pi you are going to get. 2 pi is the time period. Then e to the power of j omega n, sin omega n, and cos omega n. What is the time period? It is equal to 2 pi by omega. Same property, same as the previous property, same as the previous property. So same as the previous property, right? So therefore we can say same as the previous property. So therefore previous property, as we are doing the expanding or compressing, it will become 2 pi by omega. If it is an integer, then only periodic, otherwise not periodic. So this would always you have to keep in mind. So if this value is an integer, then only it will become periodic, otherwise it is not periodic. So therefore 2 pi by omega, if this ratio is an integer, then only it will become periodic, otherwise it will not become a periodic. So this point always you have to keep in mind. So if 2 pi by omega, if you are going to get an integer, then only we can say it is a periodic signal, otherwise it is not a periodic signal. So definitely this point always you have to keep in mind. So if 2 pi by omega is an integer, then only we can say that signal is said to be periodic signal, otherwise it is said to be a not periodic signal. So if you see clearly, e to the power of j omega naught n. Say I can write omega dash omega naught plus 2 pi k. I can write omega naught plus 2 pi k. Then what I am going to get? If you simplify, again we are going to get e to the power of j omega naught n only we are going to get. So omega naught plus 2 pi k, if you substitute and if you simplify, again we are going to get the same signal. So therefore we can say that k and n are basically integers. K is an integer, n is also integers. So what is the meaning of this signal? Omega naught and omega naught plus 2 pi k, these signals waveforms are same because they are equal. So then these two signals are equal means omega naught and omega naught plus 2 pi k. Then these two signals, even though their expressions are different, but their waveforms are same. So we can say, suppose if you say okay, suppose there is a signal which is having a frequency omega naught. If you take same signal with a frequency which is omega naught plus 2 pi k, then these two signals have the same waveform. This is possible only in the case of the discrete time domain, but not in the case of continuous time domain. So we can see in the case of discrete time domain, omega naught signal and omega naught plus 2 pi k, both the signals waveforms are same. Or in the case of continuous time domain, these two signals waves are always different. So this is what I am trying to tell you. So omega naught and omega naught plus 2 pi k, these two signals are going to remain same. So if there is a signal, so I can say like this. So basically, suppose if a signal is having frequency omega naught and if a signal is having frequency omega naught plus 2 pi k, then these two signals will have the same amount of waveform. Only in the case of discrete time domain, but these two signals have different waveforms in the case of continuous time domain. So this is what I am trying to tell you. Suppose there is a signal f of t. I want to write in terms of two signals, f1 of t plus f2 of t. So I will turn f of t as a summation of two signals, f1 of t and f2 of t. So here f1 of t has a time period t1 as a frequency of omega 1, f2 of t as a time period t2 and a frequency of omega 2. Then this signal f of t has a time period t0 and a frequency omega naught. So listen carefully. F1 of t is basically a periodic. F1 of t is a periodic signal. F2 of t is also a periodic signal. So in the case of continuous time domain, if you add or if you subtract two periodic signals, the result signal is also a periodic signal. So this point always you have to keep in mind. In the case of continuous time domain, whether you add the periodic signals or whether you subtract the periodic signals, always you are going to get the periodic signals only. So f1 of t is a periodic signal which is having a time period of t1, the frequency of omega 1, and f2 of t is also a periodic signal which is having a time period t2 and a frequency of omega 2. So if you do the addition of these two signals, we are always going to get the periodic signal because the summation of subtraction of two periodic signals, always you are going to get the periodic signal and its frequency is omega and time period is t0. So I want to obtain t0 from these two things. Suppose if you do the ratio of omega 2 by omega 1, is the rational number, then only f of t is a periodic function. So if omega 2 by omega 1, if you are going to get a rational number, then only we can say f of t is a periodic function. So basically, either omega 2 by omega 1 or you can do t by t1 also you can do. Either you can do omega 2 by omega 1 or t2 by t1 also you can do. Anyhow, it is same. So you can see either you do omega 2 by omega 1 or either you can do t2 by t1. So if these are the rational number, if this is a rational number, then only we can say the resultant signal f of t is a periodic function. So listen carefully. Either you do omega 2 by omega 1 or t2 by t1. If you got the ratio as a if you get the ratio as a rational number means any number we can represent in the form of p by q, that is called the rational number. Then we can say it is a periodic function. And what is omega naught? Omega naught is the HCF of the omega 1 and omega 2, and t naught is the LCM of t1 and t2. So these things always you have to keep in your mind. That omega naught is the HCF of omega 1 and omega 2, and t naught is the LCM of t1 and t2. What is omega naught? Omega naught is equal to 2 pi by t naught. Omega naught is equal to 2 pi by t naught. And what is omega 1? Omega 1 is nothing but omega 1 is equal to 2 pi by t1, and omega 2 is equal to 2 pi by t2. So these 2 points always you have to keep in your mind. So you can see here t naught is nothing but, so I want to tell you basically very simple thing. So suppose here, listen carefully. Suppose I got t2 by t1 is nothing but, suppose I got 3 by 5 I got, right? Then I can do the cross multiplication. So 5 into t2 is equal to 3 into t1. So this is nothing but overall time period t1. So t1 is equal to this I can assume k, and this I can assume n, like that. So t1 is equal to k into t1 or n into t2. K and m are integers only. That is the integers. So therefore, suppose if I got t2 by t3 by 5, we will do cross multiplication, we are going to get 5 t2 is equal to 3 into t1, which is called as the overall time period t1. So t1 is equal to k into t1 or n into t2, where k and m are the integers. So these things always you have to keep in your mind. So therefore we can say, suppose if you do the addition of or do the subtraction of two periodic signals, the signal is having time period of t1 and a frequency of omega 1, and the signal is having a time period of t2 and a frequency of omega 2. So do the ratio of omega 2 by omega 1. If you are going to get this as the rational number, or t2 by t1, if you do the ratio, if you are going to get a rational number, then only we can say f of t is said to be a periodic signal. Then only we can say f of t is said to be a periodic signal. So if this ratio is a rational number, then only we can say f of t is a periodic signal. If this ratio is it is not a rational number, means f of t is not a periodic signal. You can say like that. Then this resultant signal omega is equal to HCF of omega 1 and omega 2, and this resultant signal t0 is equal to LCM of t1 and t2. Here omega 1 is equal to 2 by t1, omega 2 is equal to 2 by t2, and omega is equal to 2 by t0. So these things always you have to keep in your mind. So let's go for the generalize. Suppose if you take so many signals, like any signals, all these are periodic signals. I have did the additional subtraction. You can do the additional, either you can do the subtraction. All these are the periodic signals. So this signal is having a time period of t1 and a frequency of omega 1, and this these periodic signals are having a time period of t2 and a frequency of omega 2, and these signals are having a time period of tn and a frequency of omega n. So now I want to find whether the signal is a periodic signal or not. How to figure out this one? Suppose if in case it is a periodic signal, it is having a time period of t0 and a frequency of omega 0. Then do the ratio. So omega 2 by omega 1, omega 3 by omega 2, omega 4 by omega 3, up to omega n by omega n of omega n minus 1. So do the ratio of all these things. So omega 2 by omega 1, omega 3 by omega 2, up to omega n by omega n minus 1, and omega 1 by omega n. So listen carefully. Omega 2 by omega 1, omega 3 by omega 2, omega 4 by omega 3, up to omega n by omega n minus 1. Again, omega 1 by omega n. So do the ratio of all these things. If you got all these rational numbers, then only we can say f of t is a periodic signal. But at least if any one of them is not a rational number, then we can say the overall signal is not a periodic signal. So remember, if all this ratio we are going to get the rational number, then only we can say f of t is a periodic signal. if at least one of them, if it is not a rational number, then we can say the overall signal f of t is not a periodic signal. So this is what I am trying to tell you. Either you can use the frequency or either you can use the time period. The concept is same. Either you can use omega or either you can use time period t. With the ratio of time periods, the concept is going to get wrong. So therefore, what I am trying to say is very simple. So omega 2 by omega 1 or omega 3 by omega 2 or up to omega n by omega n minus 1 and omega 1 by omega n. So do all these things. So do all these things. If you do all these things and if all these are rational numbers, then only you can say the overall signal f of t is a periodic signal. F of t is a periodic signal. In case, if at least one of them is not a rational number, then we can say the overall signal is not a periodic signal. So this is what I am trying to tell you. So now, omega naught. So what is the meaning of omega naught? So you can see what is omega, how to figure out the omega naught. Which is the HCF of the individual frequencies. HCF of omega 1, omega 2 up to omega n. So HCF means so basically it will have some numerator and denominator will be there. Because for omega, there will be some numerator. Suppose for each and every omega, there will be some numerator as well as a denominator will be there. So what we will do, then HCF of all the numerator by LCM of all the denominator. So HCF of all the numerator by LCM of all the denominators. Similarly, T0 is the LCM of the individual time periods T1, T2 up to Tn. So LCM of all the numerator by and HCF of the all denominator. So this formula always you have to keep in mind. So definitely time period will also have some numerator and some denominator will be there. All these are rational numbers. All these are rational numbers only. Rational number means the numbers in the format of P by Q. P and Q are the integers. So therefore, we can say if omega naught is the HCF of omega 1, omega 2 up to omega n, where omega you can write labeled as the numerator by denominator. So HCF of all the numbers by denominator by the LCM of all the denominators. And T0 is the LCM of the all the time periods. Is equal to LCM of numerator by HCF of denominator. So this part always you have to keep in mind. Here HCF means HCF, then do the reverse LCM. Here LCM is here LCM, then do the reverse plus HCF. So this is what I am trying to tell you. And what is omega? N1 is equal to 2 by T1. Then what is omega 1? 2 by T1. Omega 2 is nothing but 2 by T2. And up to omega n is nothing but 2 by Tn. So these things always you have to keep in your mind. So what I am trying to tell you, basically, if they are given a continuous time signal, first try to figure out the ratio of their frequencies. If you got a rational number, then only we can say the overall signal is a periodic signal. Otherwise, it is a aperiodic signal. So this is what I am trying to tell you. So this is for the 2 signals and is for n signals. How to figure out these things I have told you in a clear-cut manner. So if they are given 2 signals for this procedure, if they are n signals for this procedure, in order to figure out the overall signal time period as well as the frequency with the help of this concept. So now let's go for the discrete time domain. So for discrete time domain, I am going to tell you what is the nature. Suppose f of n is equal to f1 of n plus f2 of n. So listen carefully. If f of n is equal to f1 of n plus f2 of n, then suppose if f1 of n is a periodic signal and f2 of n is a periodic signal, their summation or subtraction is always going to give a periodic signal. So a small correction, basically in a continuous time domain, I have told some sentence in the wrong manner, but let me correct here. So listen carefully. In the case of continuous time, the summation or the subtraction of 2 periodic signals, it may be periodic or it may be non-periodic. Whereas in the discrete time domain, the summation or the subtraction of 2 periodic signals is always equal to periodic signals. So this is a concept where I came from. What is the actual concept? Listen carefully. In the continuous time domain, the summation of subtraction of 2 periodic signals, it may be periodic or it may be non-periodic. Whereas in the case of discrete time domain, the summation and subtraction of 2 periodic signals, always you are going to get a periodic signal only. If you are taking 2 periodic signals, either you are doing addition or either you are doing subtraction, always you are going to get the periodic signal only. So this is what I am trying to tell you. So this concept you have to remember. Previously I have told reverse manner. That is the actual concept. So in the case of continuous time domain, whether you are doing addition of periodic signals or whether you are doing subtraction of periodic signals, the result signal can be either periodic or it may be non-periodic. But in the case of discrete time domain, if you're taking a periodic signal, whether you are doing additional subtraction or result and something is always a periodic signal. So this is what I'm trying to tell you. So here, see, so basically here, F1 of n is a periodic signal and F2 of n is also periodic signal. So F1 of n is a periodic signal with the period of n1 and F2 of n, as I already told you, see basically in the case of converse time system, either you do the addition or the subtraction of two periodic signals, the result signal can be either periodic or it can be non-periodic. But in the case of discrete time domain, either you do the subtraction or the addition of two periodic signals, the result signal is always a periodic signal. So this is a point, this is a 100% correct thing. So this is a correct thing. So therefore we can say, suppose if F1 of n is a periodic signal, it is having a period of n1, and F2 of n is also periodic signal, it is having a period n2. Either you are doing addition or either you are doing subtraction. In the previous two cases also, either you can do addition or either you can do subtraction in the previous case also. Here I written like this. So plus or minus or plus or minus or plus or minus. So here also plus or minus. The concept is only for plus as well as a minus. So therefore in this case, F1 of n is a periodic signal which is having a period of n1 and F2 of n is also a periodic signal which is having a period of n2. I have already told you in the case of discrete time system, whether you are doing addition or subtraction of two periodic signals, the resultant signal is always a periodic signal and its periodic n. So if you want to calculate this periodic n, it's the LCM of the n1 and n2. So it is LCM of n1 and n2. So in this compulsory F1 of n and F2 of n are periodic signals. So in this compulsory F1 of n and F2 of n are the periodic signals. So finally I can say that in this case, whenever you are doing additional subtraction of two periodic signals in the discrete time domain, the result signal is always a periodic in the case of discrete time domain. Here F1 of n is a periodic signal which is having a time period of n1 and F2 of n is a periodic signal which is having a time period of n2. The result signal n, signal F1 of n as a period n, which is the LCM of the n1 and n2. In this compulsory F1 of n and F2 of n are the periodic signals. So in this way, either in the continuous time domain or discrete time domain, you can figure out the corresponding period by this method. So these things always you have to keep in your mind. So now let's go for the causal signal. So what's the meaning of causal signal? If f of t is equal to 0 for t less than 0, then it is called as the causal signal. If f of t is not equal to 0 for t less than 0, then it is called as the non-causal signal. So basically, what's the meaning of causal signal? If f of t is equal to 0 for t less than 0, then only we can say that it is a causal signal. If f of t is not equal to 0 for t less than 0, then it is called as a non-causal signal. So what's the meaning of causal signal? Causal signal means for t less than 0, its value should be always equal to 0. So its value should be always equal to 0. So for t less than 0, the signal value should be always equal to 0. Then only we can say it is a causal signal. So if f of t is equal to 0 for t less than 0, then we can say it is a causal signal. Non-causal signal means if f of t is not equal to 0 for t less than 0, then we can say it is a non-causal signal. So these things always you have to keep in your mind. So finally, I can say causal signal means if f of t is equal to 0 for t less than 0, then we can say yes, it is a causal signal. If f of t is not equal to 0 for t less than 0, then we say it is a non-causal signal. Causal signal means in simple words I can say for t less than 0, its value should be always equal to 0 for all the time for t less than 0. Then only we can say it is a causal signal. So finally I can say a signal is said to be a causal signal if f of t is equal to 0 for t less than 0 for all the time, then only we can say it is a causal signal. Suppose if f of t is not equal to 0 for t less than 0, then we can say it is a non-causal signal. Then the next concept is model signal. So what's the meaning of model signal? So by name itself is we can say model signal means it will have a finite amplitude. It will have a finite amplitude. So if mod of f of t means I am going to find the mod of the f of t. If it is always less than or equal to n means it is going to lie between some range. It is going to lie between some range only. Where n is a finite value, then f of t is said to be a bounded signal. Otherwise, it will be called as the unbounded signal. So basically, if f of t, so let me draw a rough graph. Suppose some signal f of t is there like this. So let me draw a rough picture so that you can easily able to understand. So if it is having a finite amplitude, so if it is going to lie between certain range only, so we can say it is going to lie like this. So you can see like this it is going to get like. So you can see clearly it is going to lie only between this range. So it is going to lie between this range only. So therefore we can say it is said to be a bonded signal. So otherwise, if it is not having some bonded, if suppose if it is not having any, it is not lying in a bonded, we can say if it is having a finite amplitude, then we can say it is an unbonded signal. So what is the best example? So let me draw a picture. Suppose if it is like this, it is like this, it is increasing all the way, it is increasing all the way, then we can say it is said to be unbonded signal. So bonded means it is going to lie between a certain range of the amplitude. The signal is going to lie in the certain range of the amplitude, then only we can say it is a bonded signal. So if the signal is going to lie within a certain bond of the range of the amplitude, then only we can say it is a bonded signal. So this point always you have to keep in your mind. So if the signal is going to lie only between a certain bonded range in the terms of amplitude, then only we can get a bonded signal. So modulus means always I am going to take the positive value. So if mod of f of t less than or equal to m, m is a finite value, then f of t is said to be bonded signal, otherwise it will be an unbonded signal. So finally, what's the meaning of bonded signal? So the signal is going to lie only between a certain range of amplitude. So it is going to lie between a certain range of amplitude, then only we can get the bonded signal, otherwise it will become unbonded signal. The next concept is left side signal. So left side signal means if f of t is equal to 0 for t greater than 0, then f of t is said to be a left side signal. So left side signal means the signal is going to present only in the left side but not in the right side. So f of t is equal to 0 for t greater than 0, then we can say that signal f of t is said to be left side signal. So what's the meaning of left side signal? The signal is present only in the left side but not in the right side. So therefore we can say if f of t is equal to 0 for t greater than 0, then we can say it is said to be a left-sided signal. So the left-sided signal means the signal is going to present in the left side but not in the right side. So therefore we can say if the f of t is equal to 0 for t greater than 0, then we can say the signal is said to be a left-sided signal. Then what's the meaning of right-sided signal? Reverse of that one. If f of t is equal to 0 for t less than 0, then f of t is said to be a right-sided signal. So therefore right-sided signal means something but it is going to present in the right side but not in the left side. So therefore, if f of t is equal to 0 for t less than 0, then we can say it is a right-sided signal. So finally, the left-sided signal means if f of t is equal to 0 for t less than 0 is left-sided signal, and right-sided signal means if f of t is equal to 0 for t less than 0, then we say it is a right-sided signal. So these things always you have to keep in your mind. So now the next thing is two-sided signals. So two-sided signal means if f of t is not equal to 0 for all t, then f of t is said to be two-sided signals. Means it is present on the left side as well as the right side. So the signal is going to present on the left side as well as the right side means at t less than 0 it is present and t greater than 0 also it is present. Then we can say it is a two-sided signal. So if f of t is present in both the left side means for t less than 0 it is present and for t greater than 0 also it is present, then we can say it is a two-sided signal. So if f of t is not equal to 0 for all the t, then f of t is said to be two-sided signal means for t less than 0 also it is present and t greater than 0 also it is present. So therefore we can say it is a two-sided signal. So if f of t is present, f of t is present for the left side as well as the right side. So therefore we can say it is a two-sided signal. So this is what I am trying to tell you. So therefore we can say if f of t is present for the left side as well as the right side, then we can say it is a two-sided signal. So what I am trying to tell you is very simple. Here the signal f of t is present in the left side as well as the right side. So therefore we can say it is a two-sided signal. So we can say it is a two-sided signal. So this is what I am trying to tell you. So the signal is present for t less than 0. The signal is also present for t greater than 0. Then we can say it is a two-sided signal. So therefore two-sided signal means if the f of t is not equal to 0 for all t, then f of t is said to be two-sided signal means the signal is present for t less than 0 and also the signal is also present for t greater than 0. Then we can say it is a two-sided signal. So these are the different properties of the signals we have discussed in a very detailed manner. Now we are going to discuss some more important things. These things always you have to keep in your mind, which is a to the power of n, u of n, convolution of u of n is always equal to 1 minus a to the power of n plus 1 by 1 minus a into u of n. So basically, these type of questions they are going to ask in examination. But if you take a lot of time in order to solve those numericals, it will take a lot of time. But in the examinations, you have to make things very faster. So that is the reason I recommend you to remember this, all these things that if you remember, if any question is coming in this format, then definitely we can solve in a very fraction of second, which is a to the power of n u of n convolution of u of n is equal to 1 minus a to the power of n plus 1 by 1 minus a into u of n. Then a to the power of n u of n convolution of a to the power of n u of n is equal to a to the power of n into n plus 1 into u of n. And a to the power of n u of n convolution b to the power of n u of n is equal to b to the power of n plus 1 minus a to the power of n plus 1 by b minus a into u of n. Similarly, e to the power of minus t, u of t convolution of e to the power of minus t, u of t is equal to t into e to the power of minus t into u of t. Whereas e to the power of minus at, u of t convolution of e to the power of minus bt, u of t is equal to 1 by b minus a into e to the power of minus at minus e to the power of minus bt into u of t. So all these formulas always you have to keep in your mind. So in the examinations, if they are asking the questions from these, then you don't have to solve all these things. It will take a lot of time. Instead of that, if you remember this one, it will be easier to solve this type of things. That is why I am specifically given all these 5 equations. You have to remember these values. So a to the power of n u of n convolution of u to the power of n is equal to 1 minus a to the power of n plus 1 by 1 minus a into u of n. Whereas a to the power of n u of n convolution of a to the power of n u of n is equal to a to the power of n into n plus 1 into u of n. Similarly, a to the power of n u of n convolution of b to the power of n into u of n is equal to b to the power of n plus 1 minus a to the power of n plus 1 by b minus a into u of n. Similarly, a to the power of minus t, u of t convolution of e to the power of minus t, u of t is equal to t into e to the power of minus t into u of t. Whereas a to the power of minus at, u of t convolution of e to the power of minus bt, u of t is equal to 1 by b minus a into a to the power of minus at minus a to the power of minus bt into u of t. So this is the 5 equations always you have to keep in your mind. So finally, I can say a to the power of n u of n convolution of u of n is equal to 1 minus a to the power of n plus 1 by 1 minus a into u of n. A to the power of n u of n convolution of a to the power of n u of n is equal to a to the power of n into n plus 1 into u of n. Similarly, a to the power of n u of n convolution of b to the power of n u of n is equal to b to the power of n plus 1 minus a to the power of n plus 1 by b minus a into u of n. Similarly, e to the power of minus t, u of t convolution of e to the power of minus t, u of t is equal to t into e to the power of minus t into u of t. Whereas e to the power of minus at, u of t convolution of e to the power of minus bt, u of t is equal to 1 by b minus a into e to the power of minus at minus a to the power of minus bt into u of t. So if you see clearly, so here suppose in place of b, if you substitute 1, we are going to get this one, right? In place of b, if you substitute 1, then we are going to get this one. So substitute here b is equal to 1. So what is the power of anything is 1? If this is also 1. So we don't have to remember this one. So remember only this one. So if you remember this one, in place of b substitute 1, then we are going to get this one. So I am requesting you not to remember the first one. So remember only this remaining 1, 2, 3 and 4. So remember only these 4 things. If you remember these 4 things, then you don't have to remember this one because this is so this is one of the case which you are going to get from this equation. So these 4 equations always you have to keep in mind, which is a to the power of n, u of n convolution of a to the power of n, u of n is equal to a to the power of n into n plus 1 into u of n. Whereas a to the power of n, u of n convolution of b to the power of n, u of n is equal to b to the power of n plus 1 minus a to the power of n plus 1 by b minus a into u of n. E to the power of minus t, u of t convolution of e to the power of minus t, u of t is equal to t into e to the power of minus t into u of t. And e to the power of minus at, u of t convolution of e to the power of minus bt, u of t is equal to 1 by b minus a into e to the power of minus at minus e to the power of minus bt into u of t. So I recommend you to remember only these 4 equations. So finally I can say a to the power of n, u of n convolution of a to the power of n, u of n is equal to a to the power of n into n plus 1 into u of n. And a to the power of n, u of n convolution of b to the power of n, u of n is equal to b to the power of n plus 1 minus a to the power of n plus 1 by b minus a into u of n. And e to the power of minus t, u of t convolution of e to the power of minus t, u of t is equal to t into e to the power of minus t into u of t. And e to the power of minus at, u of t convolution of e to the power of minus bt, u of t is equal to 1 by b minus a into e to the power of minus at minus e to the power of minus bt into u of t. So these things always you have to keep in your mind. So these 4 equations always you have to keep in your mind. So finally I can say a to the power of n, u of n convolution of a to the power of n u of n is equal to a to the power of n into n plus 1 into u of n. And a to the power of n u of n, convolution of a to the power of n u of n is equal to b to the power of n plus n minus a to the power of n plus 1 by b minus a into u of n. A to the power of minus t into u of t, convolution of a to the power of minus t u of t is equal to p into a to the power of minus t u of t. And a to the power of minus at into u of t, convolution of a to the power of minus bt into u of t is equal to 1 by b minus a into a to the power of minus at minus a to the power of minus bt into u of t. So these four equations always you have to keep in your mind. So finally I'm saying, which is a to the power of n u of n, convolution of a to the power of n u of n is equal to a to the power of n into n plus 1 into u of n. And a to the power of n u of n, convolution of b to the power of n u of n is equal to b to the power of n plus n minus a to the power of n plus 1 by b minus a into u of n. And a to the power of minus t into u of t, convolution of a to the power of minus t into u of t is equal to t into a to the power of minus t into u of t. And a to the power of minus at u of t, convolution of a to the power of minus bt u of t is equal to 1 by b minus a into a to the power of minus at minus a to the power of minus bt into u of t. So if you remember these four things, everything is simple. So these things always you have to keep in mind. So now we'll discuss the system properties. So we are going to discuss the different types of the different types of the system properties we are going to discuss in a very detailed manner. So we see for a system there are a lot of properties are there. So each and every property we are going to define in a very detailed manner. The first property that we are going to discuss is the linearity property. So what is the meaning of linearity? And what I told you, what's the meaning of linearity? Linearity means the system should satisfy two things, which is the homogeneity as well as the superposition. If any system is satisfying the two conditions, which is superposition, homogeneity, then only then we can say the system is said to be a linear system. So this is a system, right? The input is x of t and the output is y of t. So the input is x of t and the output is y of t. See, I've already told you, suppose listen carefully, let me give you some detailed analysis. Suppose if you take that system, so if you take the system, for the system, if the input is x1, and you are going to get the output is y1. Similarly, for the same system, if the input is x2, then the output is y2. Similarly, for the same system, if the input is x3, then the output is y3. So basically, their input x3 is nothing but it is a summation of the two previous inputs. So x3 is equal to summation of two previous inputs. Then output should be also equal to summation of two previous outputs. If this is the case, then we can say the system is said to be linear. Then only the system is said to be linear. Or suppose if the input is scaled by some factor a, then the output is also must be scaled by same factor a. If the input is scaled by factor b, then the output should also be scaled by factor b. So now the input is, now we can say what is the input? Input is the new input is summation of the two previous inputs, which is a into x1 plus b into x2. Then what is the output? Summation of two previous outputs, which is a into b1 plus a into y1 plus b into y2. So therefore we can see clearly if the input is a into x1 plus b into x2, then the output should be a into y1 plus b into y2. Then we can say the system is satisfied with two properties. One is the superposition property as well as the homogeneity property. Then only we can say the system is said to be linear system. So if the system satisfies the homogeneity as well as superposition, then only we can say the system is said to be linear system. So you can say for the system the input x of t is equal to a1 into x1 of t plus a2 into x2 of t. Then the output y of t is equal to a1 into y1 of t and a2 into y2 of t. Then only we can say the system is said to be a linear system. Means if the input is the summation of two previous inputs, then the output should be summation of two previous outputs. If the input is scaled by some factor a, then the output should also be scaled by same factor a. If these conditions are satisfied, we can say the system is said to be a linear system. So for zero input, if the system output is 0, then the system is said to be linear. Suppose if a is equal to 0, means the input is 0, the output should also equal to 0 because a is also equal to 0. So the input is 0, definitely the output should be 0. Then only we can say the system is said to be linear. So this is one of the special thing. If you first for 0 input, the output should be always 0. If this is the case, we can say the system is said to be linear. So therefore, we can say, I have already told you, for a system, if the input is a summation of two previous inputs, then the output should be it is also equal to summation of two previous outputs. If this is possible, then we can say that the superposition is satisfied. Homogeneity means if the input is multiplied by some scalar quantity A, then the output should also be multiplied by same amount of scalar quantity A. So if the A is equal to 0 means the input is equal to 0, then the output should also equal to 0 for a linear system. So for 0 input, the output is equal to 0 in the case of linear system. So this is what I am trying to tell you. So if the input x of t is nothing but A into A1 into x1 of t plus A2 into x2 of t, then the output should be equal to A1 into y1 of t plus A2 into y2 of t. So for 0 input, the output should be equal to 0 in the case of linear system. So this is about the linear system. Now let's go for the another thing which is called as the time invariant property. So now we will see what is the meaning of time invariant property. Time invariant property means suppose there is some system is there. Suppose for the system the input is x of t, and the output you are going to get y of t. Suppose if the input is delayed by some amount of time t0, then the output should also be delayed by the same amount of time t0. Then only we can say the system is said to be invariant. So for the same input we are going to get the same output. If the input is delayed, the output is also delayed by the same amount of quantity, then we can the system is said to be time invariant system. Means what is the meaning of this one? So the system is going to produce the same input, same output for the same input. So if you are going to give the same input, irrespective of the time, the output you are going to get same output. That is the thing we say it is a time invariant system. So we can say for a system, if the input is x of t, then we are going to get the output y of t. If the input is delayed by some amount of time t0, then the output should also be delayed by same amount of time t0. So these things always you have to keep in your mind. So always you have to do the operation only on the t. So always you have to do the operation only on the time t. I have already told you how to check whether a system is time variant or time invariant. I have already told you this thing so many number of times. So I no need to further explain. So always you have to do the operation only on the time t. Now t only going to do the operation. So I have already told you, if you suppose if they give you some system equation, how to check whether this is a time invariant or not. I have already told you. So for a certain input x of t, we are going to get the output y of t. So take the new input x1 of t and try to get the value of the output y1 of t. That new input x1 of t is the delay of the previous input. Then try to figure out what is the output that we are going to get. If that output is something that is equal to y of t minus t0, then only we can say it is a time invariant system. Otherwise, it is a time variant system. So always you have to do the operation only on the time t. So these things I have already told you so many number of times. So I don't need to further explain regarding this one. So now the next system property is the causal system. So what is the meaning of causal system? See, I have already told you causal signal means we can say at a t less than 0, the function, the signal is equal to 0, then we can say the causal signal. Causal signal means the f of t is equal to 0 for t less than 0, then we can say the signal is equal to causal signal. But here we are going to discuss about the causal system. So causal system means if output of the system responds to only present or the past inputs only, but no more future inputs. So what's the meaning of causal system? Here the output is independent of the future inputs. So listen carefully. For a given system, if the present output is independent of the future inputs, then we can the system is said to be causal system. And also you can say the other fashion also, if the present output is depending on the present input or the past inputs, but not on the future inputs, then we can say the system is said to be causal system. Then what is non-causal? Non-causal is very simple. Non-causal means the present output is going to depend upon the future inputs. Then we can say it is a non-causal system. So listen carefully. If the output of the system responds to only present or the past inputs only, but no more future inputs. So if a system is causal for all time, under all conditions, then only it is said to be causal system. Otherwise, non-causal system. So or even for one case, if the present output depends on the future input, then the system is said to be non-causal system. So what I am trying to tell you is very simple. So basically, suppose we take some system, and if you are going to see that the present output is independent of the future inputs, then we can say it is said to be causal system. Suppose if the present output is depending on the future inputs, then we can say it is a non-causal system. Suppose if you are going to analyze some system and you got that, so at least for one case, suppose at least for one case, you got to know that the present output is depending on future inputs, then we can say the overall system is said to be a non-causal system. Even for at least one case, if the present output is depending on the future input, then we can say the system is said to be non-causal system. Causal system means for all the time, the output should, it is independent of future inputs. If this is the case, then only we can say the causal system. So if at least for one case, if the present output is depending on the future inputs, then we can say the system is said to be non-causal system. So for a system to be causal, so no matter whatever the time that we are going to take, from -70 to +70, for each and every case, if the present output is independent of future inputs, then only we can say it is a causal system. If at least for one case, if the present output is depending on the future input, then we can say the system is said to be non-causal system. So therefore, if the output of the system responds to only present or the past inputs only, but no more future inputs, if a system is causal for all time under all conditions, then only it is said to be causal system, otherwise non-causal system. Or even for one case, if the present output depends on the future input, then the system is said to be non-causal system. So I've already told you, again let me repeat. So causal system means if the present output is independent of the future, values of the input, then we can say it is a causal system. But if the present output depend upon the future values of the input, then we can say it is a non-causal system. Suppose if you want to tell if the given system is causal or not, for each and every time, you need to check whether the present output is depending on the past values of the input or not. If that is the case, if it is independent of the future values of the input, then for each and every case, then only we can say it is a causal system. So even for at least one case, if the present output is depending on the future values of the input, then the overall system is said to be a non-causal system. So this is what I am trying to tell you. So now let's go for the static system. So what is the meaning of static system? Static system is, by definition itself, we can say the output is independent of the past values of the input. So what's the meaning of static system? Static system is the present output is independent of the past values of the input. The present output is independent of the past values of the input. Then we can say the static system. So what's the meaning of dynamic system? Dynamic system is the present output is depending upon the past values of the input. Then we can say dynamic system. So we can say static system means when present output depends on the present input, then only the system is said to be static system. Otherwise, it is said to be dynamic system. It's having memory. So output can be not equal to 0 when input is equal to 0. So basically, here if you see clearly, in the case of static system, what is going to happen? Here the present output is depending only on the present values of the input. It is going to depend only on the present values of the input. Then only we can say the static system means it is independent of the past values of the input. Suppose if the present output is depending on the past values of the input, then we can say it is a dynamic system, or we can say it is having memory. Memory means it is going to store the past values of the input also. So see suppose if it is a dynamic system, if the dynamic system is definitely it will have memory. Even the present input is 0, definitely the output can be not equal to 0 because of the past values of the input. So in the case of dynamic system, but in the case of static system, if the present input is equal to 0, then definitely the present output should it is also equal to 0 because it is going to depend only on the present values of the input. So therefore, we can say finally that the static system is if the present output, so if the present output is depending only on the present values of the input, but not on the past values of the input, then we can say it is a static system. But if the present value of the output depends on the past values of the input, then we can say it is said to be dynamic system. So in the case of dynamic system, even the present input is equal to 0. So because of past inputs, the output can be not equal to 0. So therefore, when the present output depends on the present input, then only the system is said to be static system. Otherwise, it is said to be dynamic system, which is having memory. So therefore, output can be not equal to 0 even when input is equal to 0 in the case of dynamic system. So when the present output depends on the present input only, then the system is said to be static system. Otherwise, it is said to be dynamic system. Means it is going to have the memory. So therefore, the output can be not equal to 0 when the input is equal to 0. So finally, I can say static system is if the present value of the input, if the present value of the output depends only on the present value of the input, but not on the past values of the input, then we can say it is a static system. Means we can say there is no memory to store the past values of the input. So whereas dynamic system is if the present value of the output is depending on the past values of the input, then we can say it is a dynamic system. So in the case of dynamic system, even the present input is equal to 0. So because of past inputs, the output is still here going to get not equal to 0. So these points always you have to keep in your mind. So now the next property is the stable and the unstable systems. So the next property that we are going to discuss is the stable and the unstable systems. So if for at least one bonded input, if the output is unbounded, then the system is compulsory unstable. So I already told you stable and unstable systems. What's the meaning of stable and unstable systems? By stability, for every bonded input, if you are going to get the bond output, then the transfer system is said to be stable. Even for at least one bonded input, if the output is unbounded, then the transfer system is said to be unstable system. Listen carefully. What's the meaning of bond input and bond output? If for each and every bond input, if you are going to get the bond output, then only the transfer system is said to be stable. Even for at least one bonded input, if you are going to get the unbounded output, then the system is said to be unstable system. Listen carefully. What's the meaning of stable and unstable systems? I already told you. For each and every bonded input, if you are going to get the bond output, then only the transfer system is said to be stable system. Or even for at least one case, even for at least one bonded input, if you are going to get the unbound output, then we can say it is a unstable system. So even for at least one bonded input, if the output is unbounded, then the system is compulsory unstable. So finally, I can say like this. So what's the meaning of Weibull stability? Means for every bonded input, if you are going to get the bond output, then you can the system is said to be stable system. But even for at least one bond input, if the output is unbounded, then we can say the system is said to be unstable system. So these things always you have to keep in your mind. So we have discussed about all the system properties in a very detailed manner. So these system properties always you have to keep in your mind. So there is one more system property which is a invertible and non-invertible system. So this is a last property regarding the systems. So this is a last property regarding the systems that we are going to discuss in detail. So invertible and non-invertible systems that we are going to discuss here. So listen carefully. Suppose there is some system, yes. So there is some system, yes. So for the system, I have given the input x of t, then I am going to get the output is y of t. So this y of t, I am going to give the invertible system. If I give this output y of t to this invertible systems, then again I need to get the x of t. The input I should get back. So we can say for x of t, see for this system, yes, I have given the input is x of t, and the output I got y of t. So I have taken another system, which is the invertible system. For this system, this is the invertible system. For this system, if I give this input again y of t, then again you should get the output that input x of t. Then only we can say this is a invertible system. Otherwise, if you're not getting the x of t, then you can say it is a non-invertible system. So SI is called as the inverse system of the S. So this is called as the inverse system of the S. For unique input, if the output is unique, then the system is said to be invertible system. For unique input, the output is unique, then only we can say the system is said to be invertible system. So for every unique input, you should get a unique output. Then we can say the system is said to be invertible system. Suppose you take y is equal to x square. Suppose y is equal to suppose it's some system y is equal to x square is there. Suppose there is some system with the relation y is equal to x square. Suppose for x is equal to -1 and x is equal to 1, what is the output that you are going to get? 1. So you can see then output doesn't know for what input you got the output. So here there is for many input you got the same output. So this is not a invertible system. For unique input, you should get only unique output. So for every unique input, you should get a unique output. But in this case, for many inputs, you got the same output. Then this is the non-invertible systems. For every unique input, you should get a unique output. So then for every unique output, then you are going to get a unique input. So then only we can, the system is said to be invertible system. For unique input, if the output is unique, then the system is said to be invertible system. So for every unique input, you should get a unique output. Then only we can say the system is said to be invertible system. So we can say here SI is called as the inverse of the system. So for every unique input, if you get a unique output, then only we can say the system is said to be a invertible system. So you can see for this one, for many inputs, you got the same output. So this is not a invertible system because for every unique input, you should get a unique output. Then only the reverse is also true. For unique output, there is a unique input also. So that then only we can say it is called as the then we can say it is called as an invertible system. For every unique input, if you got the unique output, then only we can say the system is said to be invertible system. For non-zero input, if the response is 0, then the system is compulsory non-invertible system. For non-zero input, if the response is 0, then the system is compulsory non-invertible system. Suppose this statement always you have to keep in your mind. See, for non-zero input, if the response is 0, then the system is compulsory non-invertible system. So basically, see, suppose for non-zero input. So for non-zero input means, suppose if you give non-zero input like, listen carefully, suppose like -1, +1, and +2. So, but still, we got the same answer as 0. So, then we can say for many inputs we have unique output. So definitely we can say this is a non-invertible system. And what I told you, for every unique input, you should get a unique output. Or you can say for every unique output, there should be unique input. But in this case, for many inputs, we have only one output. So one unique output. So therefore, because of this, we can say it is a non-invertible system. So therefore, for non-zero inputs, if the response is 0, we can say it is a non-invertible systems. So this is what I am trying to tell you. So what's the meaning of invertible systems? For a system, yes, if you are going to get the input is x of t, then you are going to get the output y of the pi, then the output is y of t. So again, if you are going to keep on the system, most of the system, if you keep there, and if you give y of t as input, then you should get the input as x of t. If this is the case, then only we can say it is a invertible system. So for every unique input, if you get a unique output, or for every unique output there is a unique input, then only. So you can say really for every unique input you got the unique output, and for every unique output you should get a unique input. Then only we can get the same input here. Then only we can say it is a invertible system. Suppose for many inputs, if you got the same output, then definitely we can say it is a non-invertible system. Non-invertible system. Or we can say for non-zero input, if the output is 0, then also we can say the system is said to be non-invertible system, because for many inputs the output is 0. So then also we can say the system is said to be non-invertible system. So these things always you have to keep in your mind. So these are the properties of the system that we have discussed in a very, very detailed manner.